First, let us do a revision of what we saw yesterday. We'll spend some 5 minutes time revising what we covered yesterday, and then we'll proceed ahead. We saw the very basic data types yesterday. We saw first what are lists. Then we saw dictionaries. Then tuples, set. Anything else did we cover apart from this? Okay. So if I have to write down the properties of these data structures with respect to they being ordered and mutable. Let us write their properties with respect to this. So ordered means that they support indexing. Mutable means can be changed. Okay. Now lists, are they ordered? Help me fill this, guys, with a tick mark or a cross mark. Lists, are they ordered? Yes. And mutable, are they mutable? Yes. Dictionaries, are they ordered? No, they are not ordered. And are they mutable? Keys, they are not. Values are. Okay, values are mutable. Tuples, are they ordered? Yes, but they are not mutable. Similarly, sets, they are neither ordered nor mutable. So these are the salient features of the data structures that we saw yesterday. Apart from this, what else did we see? We saw loops. We saw the basic loops used, the syntax. We saw if for loop. So for I in a list, then we give the colon, and after indentation we write the lines. Okay. Similarly, we saw while loop. So while we give some condition here, okay, and then indentation, and then we write, and then this must have an increment. So let's say something like this. This must be there, okay, which at some point violates this condition for the loop to stop. If you do not have an increment, whatever the condition, it will always be true, and the loop will get into an infinite spiral. Okay, so to avoid that, you must have a condition here, an increment here, and that increment at some point of time must violate this condition for the loop to stop. Then we also saw if else if loop. So if condition 1, you give indentation and you write, then elif condition 2, again indentation, you write the steps. Similarly, you can go on and on. You can give as many conditions as you want, but remember at the end you can directly use the else condition. So that if none of the conditions are satisfied, the else condition is executed. So this is if elif condition. Then we saw basic stats yesterday. We saw what is mean, median, mode. So these are very basics. We already know this from high school. What additional we learned? We learned what is a histogram. So a histogram, it helps us understand the distribution of a variable. Okay, how is a variable distributed? It is used for quantitative variables. So how do we draw a histogram? We have the variable on the x-axis, whatever is the variable, and then we divide the variable into small ranges. Okay, we divide the variable into small ranges, and for each range we count how many values of the variable are falling in that range. Okay, and that count is represented on the y-axis. So take any variable and divide it into smaller ranges, and these ranges must be equal. Okay, divide it into smaller equal ranges. Let's say in intervals of 5 you have divided, and then you count within this 5 interval how many values of that variable falls, and just increase the height of the bars to that, and so on. Okay, so this is a histogram. Now in what intervals do you divide your variable? I have given 5 here. That depends on how granular you want to see the data. Okay, so later we will see in Python, when we run this, we will use a parameter called bins. So bins is nothing but these are bins, individual bins. So we can vary that parameter. We can give some number. Let's say if we give 50, it will be divided into 50 different small intervals. Okay, and if you give 100, it will be divided into even smaller intervals. So the more interval you give, the more granular the data gets. So one example I can show you here. So this is an example of a histogram. See, this is a histogram. So here I have not given any bin parameter, so it has taken a default value for it, but you can, if you want, you can give the bin parameter. So the more higher number you give, the more granular the histogram gets. So we will talk about this today in details. Okay, anything else did we see yesterday apart from this? No, I think, okay, the range function, yeah. We saw the range function. So what does the range function do? So range function takes 3 inputs. First is the starting number, then the ending number, and then the increment. Okay, so for example, you can give range 5 comma 23 comma, let's say again 5. So this means the value will start from 5, and this 5 will be added to it, so it becomes 10. Then again another 5 will be added, 15, 20, and once again if you add 5, it becomes 25, which is outside this range. So the numbers will always be between 5 and 23, both inclusive. So this is what the range function does. It will be helpful later when you start doing things, when you start cleaning data, you will realize when you have to run through a loop, then you can use the range function for that. Okay, so let's move ahead now. We will continue on the data types. Okay, continue and break. Yeah, we also saw what are continue and break. These are not very popularly used. So continue and break, these are both used in loops. These are used in loops when you have to skip iterations. So what is a loop? A loop is basically multiple iterations running one after the other. So sometimes, depending on certain conditions, you might want to skip a iteration. You might want to skip whatever is being done in individual iterations. That is where you use continue and break. Okay, to skip iterations. So continue, what it does, continue, it skips only the current iteration. And break, it skips all iterations. Okay, that is the difference between continue and break. Okay, so let's start with today's topic then. We will be talking about comprehensions in Python now. Comprehension is another data type, okay, which are very similar to list. These are very useful. These are very useful to do small operations on individual elements of a list. These are very useful. So let's see, why do we need comprehension first? So let's say you have a list x is equal to 1, 5 and 11. So this is a list that we have. Now if I ask you to multiply each element of the list by 2. So let's say I ask you multiply each element of the list by 2. How would you do that? If you write x multiplied by 2, what answer you would get? You would get answer as 1, 5, 11 and again 1, 5, 11. This is the answer you will get if you do this. X multiplied by 2. It will just repeat the entire thing twice. Okay, so let me show you this. I'll insert a cell above. So see, the entire list is being repeated twice. If you give 3 here, it will be repeated thrice. Then how do we multiply individual elements of the list by 2? The current option that we have, since we have seen loops already, we can use a for loop to do this. So I can write for I in the name of the list and I can print I into 2. So what this will do is individual elements it will pick from the loop and it will multiply by 2 or whatever you are doing here. So this way you can multiply the individual element by 2. So this is a little tedious because you are creating a loop just to multiply elements by 2, and it is also time taking. So if your loop is very big, it will not be the most efficient way to do things. So how else can we do the same operation? We can use a Python comprehension for this. So that's what we'll be learning for it. We can use a Python comprehension to do these small tasks. So what is the syntax of a Python comprehension? The syntax is like this. So first you do what you want to do, and then you define the variable, and you have to enclose them within square brackets. Okay, so they are also known as Python list comprehension because they look like a list. So you have to enclose them as well with a square bracket just like a list. So what do I mean do what you want to do? So usually what is the syntax? Whenever you try to do something, you first define a variable and then you perform an operation on the variable. So for example, if you have to access individual elements of a list, what will you write? You will write for I in a list and then you can write I into 2. So what is the syntax? You first defined what is I for I in a list and then you used I and multiplied it by 2. This is the syntax. But here it is opposite. You first do what you want to do and then you define the variable. So opposite syntax of what we used here. So how will it look like here then? You will write I into 2 and then you will write for I in a list. Okay, so first I did whatever I wanted to do. I wanted to multiply every element by 2, so I wrote I into 2 and then I wrote what is I for I in a list. Now this will define that I is coming from this list. So this is the syntax. Initially it might be a little unusual to you, but as you start practicing you will become comfortable. So for example, I have written here I into 2 for I in a list. If I run this, okay, I have not defined the list. Let me run this one first. So I get this. Each element of the list is multiplied by 2. So this is my list. My list is 1, 2, 3, 4. Each element is multiplied by 2. Now these are faster than loops. Okay. Comprehensions are faster than loops, so they are more efficient. And they save you coding space also. So previously what you were using a loop to run, you are just running it in one line now. So in one line you are running what you were running in multiple lines previously. So this is a Python comprehension. Is that clear, guys? So let us see some more examples of Python comprehension. Now here I have an entire sentence. I have an entire sentence here and I have the split function. So dot split function. What does the split function do? Let us see. So if you have a variable, a character variable, let's say you have a variable. So let's say the variable is Python is the best language. Now, if you want to split this sentence based on the spaces, you can see the spaces. If you want to split the variable based on the spaces, the syntax to do that and the function to do that is split. Split function splits a variable based on any character that you want it to. Okay, so if I write x dot split and I just give a open close braces, what I will get individual words. I will get Python, is, the, and so on. So individual words I will get as a list. So this output I'll get as a list. Okay, right now it is one single entity, but if I run this function I will get individual elements in a list. So I can write x split of 0. 0 will give me only Python. If I write 1 I will get is. If I write -1 I will get language, and so on. Now you may ask, I did not give any character here. Why did it split by the space? Because by default it splits by space. Okay, if you want to give something else you can put that in quotes here, but by default if you don't give anything, Python understands that you want to split it by a space and it will split the data by a space. So that's what I'll be doing here. Here I want to split this entire sentence by a space, so I have just written dot split. Now when I run this, this is the output I get. Now notice the output is a list. The output is a list. So if I write words of 0 I will get this. If I write words of 1 I will get this, and so on. So this is a normal list, and we already saw how do we use indexes in a list. So this is -1, this is -2, -3, and so on. Now there are other functions in Python. So for example, we have the dot upper function. What does the dot upper function do? The dot upper function converts your characters to uppercase. So what have I written here? I have written, I'm using a comprehension now. See, I have written w dot upper, then I gave a comma and I have written w dot lower, and then I have given length of w. So length of w, what it will do, it will count the number of letters in w. Now what is w? I have not defined yet because I'm using a comprehension. So remember, in a comprehension first you do what you want to do and then you define the variable. So that's what I'm doing. I'm finding out the upper and the lower and then the length of w. Now I'm defining for w in words. Words is what I previously splitted here. So if I run this, I will get everything in stuff. Stuff is another list. I have assigned it to another list, and then I can print it using a loop, or I can print it using a normal comprehension also. So what am I getting? I'm getting each individual words here, first in uppercase, then in smaller case, and then the length of that word. So I have 3 characters in the, so I'm getting 3 here. I have 5 characters in quick, so I'm getting 5, and so on. So this is another example of how comprehension can be used. So see, I could easily do this in just one sentence. Else you will have to use a loop, and within the loop you will have to write at least 2-3 sentences to do this. I did that very easily in one sentence. So that is the advantage of using a comprehension. It reduces the amount of coding required. Is this clear, guys? Any questions on this? I think it is fairly simple. The more you practice, the more you will remember. There is nothing difficult here to understand. You just have to practice and remember the syntaxes. And it is very easy. So don't worry about the syntax now. You may be looking at it for the first time, so it might look difficult. But if you practice it a few times, you will easily remember it. Now, I can give a condition also in a comprehension. So, for example, let's say if I want to print all even numbers between 1 to 20. So even numbers means I have to put a condition that only if I divide the number by 2 and only if the remainder is 0, it is an even number. So how will I do this using a comprehension? You can easily do this using a loop. So you would have done it already probably in your high school or graduation. You would have done if you have experience with some amount of coding. But how will you use a comprehension to do this? So I can write I for I in range. So I have just written I because I just want to print the result. I'm not performing any operation on it. So I just want to print the result. So I have written I. Now for I in, I have given this range. Why this range? Because I want to find out all even numbers between 1 and 20. So I have given this range also, and then I have given a if condition. If I percent 2 means remainder of I when it is divided by 2, if it is equal to 0. So what this would do is it will print I only if this condition is valid, otherwise it will not print I. Okay, so again the same syntax. First you do what you want to do, and then you define I, and after defining I, if you have any conditions you can give. So that's what I have done. So the conditions will come at the end. So you define the variable and then conditions if any. If you have any conditions, you can write that at the end. No, it wouldn't print 20 because the range function gives you only from 1 to 19. It will not print 20. This we saw yesterday. The range function will only give you one less than this number, not till this number, one less than that number. Okay. So see this, for example, it has printed only till 4. It has not printed 5. Okay. So if you wanted till 20, you will have to give 21 here. Yeah, of course, Arpita. If you use an increment of 2, there is no need to use condition. But this is just an example. Okay. Now, where else can a comprehension be useful? A comprehension is very useful when you have to subtract two lists. So let's say you have a list and you have another list, and you want to find out which are the elements which are common to both the list. So how many elements are common to both the list, or which are the elements which exist in both the list? Or in another way you can say, I want to find, I have two lists, let's say A and B, and I want to find A intersection B. or if I want to find A minus B, or if I want to find B minus A. So whenever you want to find the common elements between two lists, or you want to subtract the elements of one list from another, you can use comprehension. Okay, they are very helpful and you have to do this. So what is the syntax for that? Similar to what you do in comprehension. So I have defined two lists here. One is X, which has 1 2 3. Another is Y, which is 2 3 4 5. Now what do I want to do? I want to do a X intersection Y here. So how will I write? I just want to print the common element. So I will write I only. I'm not performing any operation. And then I will write I for I in X if I in Y. So in the condition I have given if I is also present in Y. So the first is I for I in X. That means all elements of X will be considered. But then I am giving a condition if only I is present in Y. So that means if I is present in both of them, they will be considered. Hence I am getting only 2 and 3 because 2 and 3 is present in both. So this is A intersection B. Again, this syntax might be a little unusual for you since you are looking at it for the first time, but with practice you will become comfortable. Okay, and this is very like if you are asked to write the pseudocode of any language, you would probably end up writing something like this. So this is how you would write in English language also. I for I in X if I in Y. So that is why Python, it's very easy to learn because it is very analogous to a language. So how you would write a pseudocode, the script is also like a pseudocode. So I for I in X if I in Y. Now similarly, if you have to do A minus B, you can write the same I for I in X if I not in Y. So not in Y means you are doing A minus B. Okay, so you get only 1 here. 2 and 3 is not printed because they are present in Y also. So only elements which are present in X but not present in Y is printed. And similarly, if you have to do reverse, you just put Y here and interchange X and Y, then you will be able to do B minus A. Okay, so this is a very useful application of comprehension and this is something which we use a lot. Okay, you may have to find the intersection or subtraction of a list from another very commonly. Okay, and these are asked in interviews also. So you might have multiple choice questions which ask this for as a question. Any questions so far? Okay, Shiva Kumar is asking 5 is not in X. No, you are doing A minus B, X minus Y you are doing. So only elements which are in X but not in Y will be printed. I'm not doing Y minus X. If I do Y minus X, I will get 4 and 5. Okay, there's a difference between X minus Y and Y minus X. I'm doing X minus Y here. So elements in first but not in second. Not elements in second but not in first. Okay, that is different. There's a difference between A minus B and B minus A. Okay. Yes, it will get more complicated, Anil. So it depends on if you are very comfortable, then you can go for a nested list. Otherwise, you try to avoid it, and you can easily avoid. You don't have to. You can do complex tasks even while avoiding nested lists. Okay, now let us move to the next data type, which so we'll start learning a new library now. This library is called numpy. Okay, numpy is a very popular library. What is a library? A library is something which is like outside of Python. So Python, when it came as a scripting language, it had just the commands that we learned so far, but later new libraries or new codes were added to Python. Okay, these are known as libraries. So numpy is one of the library which is used for mathematical computations. So matrix multiplication and all these mathematical operations can be performed using functions which come from the numpy library. Okay, so we will learn about the numpy library now. After this we have another library which is very popularly used, which is pandas. So we'll learn about numpy first and then we will move to pandas. Numpy is used for mathematical operations. Pandas is used for data cleaning and data manipulation. And later we will see some libraries from data visualization also. We will see the matplotlib library and the Seaborn library. So matplotlib and then Seaborn we will also see. And here we will look at pandas. So pandas is used for data manipulation. Okay, so first we have to, before we start using any function from a library, we have to load the library on our current system. Okay, so numpy, it comes pre-installed. When you install anaconda, it comes pre-installed. Some libraries are not pre-installed, so you will have to install it. Later we will see how do we install a library, but right now numpy, it comes pre-installed when you install anaconda, so you don't have to install it, but you will have to load it on your Python console. Okay, so loading is mandatory to use the library. So how do we load it? We use this import function to load the library. So what have I given here? I have given import numpy as np. Now this is optional, this is not mandatory. Why did I write as np? So the syntax of using any function in Python is, you write name of library, the name of the library from which that function came, dot the function name. Okay, and then the inputs to that function. Now this is the syntax. Now sometimes it becomes painful to follow this syntax. Why? Because sometimes the name of the library might be very big. So every time you use a function from the library, you will have to write the name of the library and then the function. So if you have a library which has a very big name, it is very painful to write the name again and again. So what Python allows you is, Python allows you to give aliases to your library names. It allows you to give shortcuts to your library name, so that instead of using the entire name of the library, you use that shortcut instead. So this saves you effort. Okay, so that shortcut is what I have given here. Import numpy as np. So this np is a alias or a shortcut which I have given to the library numpy. So now going forward, I will be using np as the name of the library, and whenever I use np, Python will understand that I am referring to numpy. Okay, so for example np.array. So that means Python will understand that I am calling this array function from the library np. So we use this function to load the library and to give it a alias also. So let us do this. I will load the library, just run it. It will not show anything, it just ran. And then we will see the first data type which is used in numpy, and that is the array. Okay, we will use arrays. So here I have defined a list. This is a normal list which has 3 elements, 1 2 3. And now if I convert it to an array, I will use the np.array function. So I have written np.array and given the input x here. Okay, now if I write the type of this double x, you see it gives me numpy array. So this is the data structure here. Now you may ask, what is the difference of, so next if I print the array, I just get 1 2 3 with the word array before it. So what is the difference between array and a list? Let us see what is the difference. So numpy, and we have array. So arrays can have only one data type. So remember we saw list last time. List can have multiple data types. They can have a character and a number together, but array will only have one data type. So it can either have character or a number. It cannot have a mixture of both. Okay, so that is one difference between array and a list. Now what if you forcibly try to give multiple data types? Let's say I have defined a list here x which has two data types. First is a string and the others are numbers. Now if I try to convert it to an array and if I print it, see what happens. Python converts all the elements to a character. See, these one are also put into quotes. That means they have been converted to characters. Since arrays cannot have multiple data types, Python will forcibly convert them to a single data type. So we should be careful when we are designing a array, so that we are not doing something like this. So you may not realize it, and Python will automatically convert it without showing you any information or any error message. So we have to be careful when we are dealing with arrays. Is that clear? The difference between arrays and lists? Okay. Now there is one more difference. Now you may ask, why do we need an array? Why do we need an array? We need an array because it has one very important property. Okay. And that important property is this. So if you have an array, let's say, if you have an array, let's say 1, 5, and 9, and then if you multiply that array by 2, what happens? You get this as the answer. So you can access individual elements in an array like this. So I just wrote x into 2, and what I got is each element was multiplied by 2. So remember, in the list this was not possible. In the list, when you multiplied the list by 2, the same elements got repeated twice. Okay, so what is this property known as? This property is known as broadcasting. Okay, so arrays, they support broadcasting. Okay, what does this mean? This means that you can perform operation on individual elements directly. Okay, directly in the sense by using the name of the array. In a list it is not possible. You will have to use a loop or a comprehension to do it. So for example, if this was a list, you cannot write x into 2 and multiply each element by 2 if it is a list. You can use a comprehension or a loop to do it, but in an array it is directly possible. So it is very easy. So sometimes when you have to do this operation, you will want your x to be an array. Otherwise you will have to use a loop or a comprehension. So that is the advantage, and that is the difference between a list and an array. So two differences. One is that arrays can have only one data type, and the second is that arrays, they support broadcasting. Okay, is that clear? Okay. Now one another property of a array is that arrays can go into two dimensions also, unlike a list. A list is always in one dimension, but arrays can go into two dimension. So we are slowly moving from one dimension to two dimension. Okay, so arrays can go into two dimension. How can we take arrays to two dimension? We can take arrays to two dimension by using the reshape function. So this is the reshape function. How do we do it? We just write the name of the array. So this is the syntax to do it. We write the name of the array dot reshape. Okay, so dot reshape is used when you want to convert a one dimensional array to two dimension. Okay, and then you write the number of rows you want and the number of columns you want. Okay, so first the number of rows and then the number of columns, and you should be careful that this into this is equal to the total number of elements. So let's say if you define an array like this 1 5 9 and 11, I can use, let's say if this is x, okay, and think that this is an array. So this is np dot array. Now if you write x dot reshape and if you give 2 comma 2, that means you will have 1 5 and 9 and 11, you will have this. So this will be your array. Now let's say if somebody writes 3 comma 2, you will get an error. If you write 3 comma 2, you will get an error because 3 comma 2 means there should be 6 elements in an array. Only then you can write 3 comma 2, but there are only 4 elements. So from these 4 elements, Python will not be able to give you a two-dimensional array which has 3 rows and 2 columns. So it will throw an error because there are only 4 elements. So you will have to be careful when you convert 1D to 2D. So for example, if this is my array, it has 20 elements. I have used the range function to get this. So if there are 20 elements, I can write 2 comma 10. So 10 into 2 is 20, which is equal to the number of elements. Okay, so if I write x dot reshape 5 comma 7, this will give you an error. Okay, this gives an error. So that is another advantage of using an array, that you can take it to two dimension. Is that clear, guys? Are arrays clear? So you will remember these once you start practicing. I'll make sure you get enough assignments to practice this. So don't worry, too many data types and they are almost similar, but once you practice you will remember them. They are very easy to remember. And there is just one or two more data types left. So there's not a lot of them, just two more, and we are done with the data types. Okay, so let's move ahead. Now another advantage of using array is that you can apply conditions on array. So see, what have I done here? I have defined my y. So y is the array which is two dimension. This is my y. So this is my x first. Okay, this is my x, which is a one dimensional array. You can see everything is in one line. Now if I use the reshape function x dot reshape 2 comma 10, what do I get? I get this. Now this becomes a two dimensional array with elements 0 to 9 as the first row and 10 to 19 as the second row. Okay, now I can apply conditions on individual elements on the array. So for example, this is just a blank line I am giving here. So slash n means a blank line. So I have a line here, a space here. Then what am I doing? I'm writing print y is greater than 5. So what this would do is it will go and apply this condition on each individual element of that array. So remember, arrays, they support broadcasting. That means you can apply conditions or you can apply operations on individual elements of an array. This is not possible in a list. Lists do not support broadcasting. So what it will do, it will check if each element is greater than 5, and it will return a boolean. It will return true or false. True if the condition is valid, false if the condition is not valid. So y is greater than 5. Is 0 greater than 5? No, so it gives me false. Is 1 greater than 5? No, so it gives me false, and so on. So from here onwards it will start giving true, and that is what is happening. From 6 onwards it is giving you true, because this condition is valid for all these elements. Okay, so this is what you are getting. Now let's say you want to print the elements which are true for this condition. So right now what have I done? I have just printed true or false. Let's say this is not your goal. Your goal is to print the elements which are valid for this condition, or which satisfy this condition. So that also can be done very easily. So let me show you how will you do that. You will just write the same, but you will put this in brackets. You put this in square bracket, and outside of the bracket you write y. So what this will do is, this will print you, sorry, I wrote double y. Even my y is not defined, so let me run this. Yeah, so now I have given y, and then within bracket I have given, we will see, we will see. So hold on for some time and you will see where multiple dimension arrays will be used. Okay, so I'm covering only things which we'll be using ahead. Okay, so all the things that I cover in my course, so that is one of the key differentiators of my course from any other course from any institute. So I teach only stuff which I have used at office and which I know you will be using when you work in data science. I will not teach you any theory which does not have any application. Okay, I cover only things which are required by a data scientist while at work. I will not teach you anything which is just theory. There are a lot of things in data science, even a year, even if you take a course which lasts for a year, you will still have a lot of things to study. Okay, but I will not cover you things which are not important, which are just theory. I will cover things which are pure application based and which you will be using. So all these things you will be using ahead. Okay, so what do I have now? So I have just printed all the elements which are true for this condition. How did I do that? I just wrote y, which is the array, and then within square brackets I wrote the condition. So y is greater than 5, and see what am I getting? I am getting only elements which are greater than 5. This is my y. So this is just a boolean. If you just write the condition, you will get a boolean vector, and then if you want to extract the elements which are true for that condition, then you write in this syntax. Okay, so this is how the syntax is. If y is an array, and if you write y is greater than some constant, you get a boolean as an output. If you want to get the elements which satisfy this condition, you will have to put this in square brackets and write y here. Okay, so how this would evaluate, let me write this. Let's say y is this. This is your y. Okay, and you have written, let's say this is 6. So if you write first, if you write y is greater than 6, what will you get? You will get false, false, true, true. This is what you would get. If you write y greater than 6, this is equivalent to writing y false, false, true, true, right? This is equivalent to writing this, because this is equal to this one. So I have written the same. So now what it will do, it will only print the true ones. It will not print the false ones. Okay, so it will print you 9 and 11 only. Okay, and this output will be a list. It will print that as a list. So look at the output, it is printing that as a normal list. Okay, now similarly you can give multiple conditions also, not just one condition. You can also write y in square brackets condition 1 and condition 2. So you are giving an AND condition. Only if both are true, it will be printed. Or you can give OR condition also, condition 1 or condition 2. So this is OR. So only if both the conditions are valid, you will have your Y printed. Okay. So this is with AND condition and this is with OR condition. So here are some examples. So since your Y, which is a two-dimensional array now, you can extract individual elements. So how will you use indexing now? Remember indexing, you used to access elements by using the index. Now the index will also get two-dimensional because your matrix is two-dimensional. Your index will also be two-dimensional. So for example, if you write y 0, 0, that means you want the element which is at 0th row and 0th column. So it will be something like this. Let's say if you have this as the array, let's say this is the array, two-dimensional array which has 3 rows and 3 columns. Or let's say, let me give you 4 rows and 3 columns. So the index of this row is 0, the index of this row is 1, index of this row is 2, the index of this is 3. Similarly, index of this column is 0, this column is 1, and this column is 2. Indexing always starts from 0. And let's say if this is y, if this is my y, if you write y 0, 0, this is how you index, right? Remember in a list we were indexing like this. But now since you are in 2 dimension, you'll have to use 2 indexes, one for the row and one for the column. So the first one is for row, second one is for column. So what does this mean? This means you want 0th row, you want 0th row and 0th column. So the output of this will be 0. Similarly, if you write y of 1, 3, what does this mean? This means y, 1, 2. This means you want this row, right? You have written 1 and you want this one. So 12, you will get 12 as the output. Okay. Now you can access multiple elements also. So right now I'm doing only one at a time. You can access multiple elements. How will you do that? So you can write y of 0 and comma. You can write 0, comma, let's say 3. You give this colon. What does this mean? This means you want 0 and 0, 1, 2 till 2, 1 less than 3. Okay, so it will print you this entire thing. So 0, 0, that means it will print you this one. 0, 1, it will print you this one, and 0, 2, it will print you this. So this entire first row you will get if you do this. Okay, 0th means first row and 0th column, first column, second column. So these are some examples which I have shown here. Here I have written 0, 1, 3. That means it will pick elements from the 0th row, which is the first row, and the second column and the 4th column. Okay, 1 means the second column because the column number starts from 0, and 3 means the 4th column. So that means I'll get 0th row, which means this row, and the second and 4th column. So second column is this and 4th column is 3. So 1 and 3 I should get. This is what I'm getting, 1 and 3. Okay, and similarly other examples also. So all these are simple, just individual elements. And you can give this also. This is something a little strange. See, I have just given colon and I have left it blank. So blank means till the end. If you leave it blank, it means Python will understand that you want till the end. That is why you have left it blank. So it will give me 3 onwards till the end. So third column onwards. So this is 0th, first, second. So from here till the end. Okay, this is the second row. Okay, this is on column, so it will print me first row and fourth onwards, so fourth column onwards, so first, second, third, fourth column onwards, so it will give me this lot. Okay, and that is what it is giving me: 13, 14, 15, 18 and 19. Is this clear, guys? Do you follow all these examples? I'll just pause for a moment. Think about this. Think about what we have seen here. I'll pause for a minute here. Yes, of course, Bharti. The same can be done for rows also. Yes, you can do the same for rows also. Okay, Harsh wants one more example. Yes, sure. So let me give you one more example here. So let's say you have y, which is this. Okay, and if I write, let's start from the basics. I want y comma 3. Let's say 2. What will I get? So this means the row number you want. So this is row starting from 0, 1, 2. Similarly, column starting from 0, 1, 2. So this means I want first row and this one. So it will give me 6. Okay, is this clear, Hers? Similarly, let's see now y 0 comma 2, and then let's say I'll give -1 here. What will I get now? I can use negative indexes also, now that you have learned about a list. So 0 comma 2 means I will get 0 till 1, not 2, excluding 2. Okay, that means I will get this, I will get this. And what column do I want? I want the -1 column, which is this. That means I want 11 and 6. So I'll get 11 and 6 as the output. Is this example clear? Just look at y and look at this example. Okay. Similarly, I can give 1:2 and let's say 0:2. I can give both. I can use the colon at both places. What will this give me? 1:2 means I'm referring to only the first row. First row, and which columns? I'm referring to column 0 till 1. So that means 0 and 2. I'll get 0 and 2 as the answer. Now is it clear? Shiva Kumar, we covered this yesterday. -1 means it starts from the opposite side. So this is -1, this is -2, this is -3. Okay, similarly, this is -1, this is -2, this is -3. Okay, so you either use from this direction or you use from that direction. If you use from the end, you give a minus there. Okay, the same way. Okay, sorry, I had paused myself. Yeah, so we saw two distributions yesterday. One was uniform distribution, the histogram for which remained flat, and the other was normal distribution, which looked like a bell curve. Okay, now let us see some functions. So what is this function that I have written here? np.random.rand. Okay, and 10. So this comes from the numpy library. That is why I have np word here. Dot random, it means it generates random numbers. But random numbers from where? This will give you random numbers from a uniform distribution. Okay, from a uniform distribution, this will give you random numbers. So how many random numbers? 10 random numbers. And between what? So by default, it gives you random numbers between 0 and 1. Okay, so that means there is a distribution like this, and from this distribution it will pick random numbers. So you have these other decimal numbers here. From these decimal numbers it will pick random numbers for you. This is what np.random.rand function does. So you see all these numbers, these are all numbers between 0 and 1. Why between 0 and 1? Because by default it gives you numbers between 0 and 1. So if I press shift tab, I will get the help page here and see what is it written here. Random samples from a uniform distribution over 0 and 1. Okay, so you can give some other numbers also here, 3 comma 2. That means it will give you random numbers, two-dimensional random numbers. It will give you an array which is of 3 rows and 2 columns, and all the numbers will be from between 0 and 1, from a uniform distribution between 0 and 1. Okay, this is what this means. So right now I have just given 10. That means I'll get a one-dimensional array. I'll get a one-dimensional array with 10 random numbers, all in one single row. Okay, this is one-dimensional. Similarly, I have another function called np.random.randn. You see there is one n additional here. So this n means it comes from a normal distribution this time, not from a uniform distribution. Okay, so this is coming from a normal distribution. Now, normal distribution, we saw yesterday that normal distribution will have some average and it will have some standard deviation also. We learned about standard deviation also yesterday. Okay, so these numbers are coming from a normal distribution this time, not from a uniform distribution. Okay, so you see some negative numbers. So it is a normal distribution which has 0 here. So some numbers are positive and some numbers are negative. So that is why you see some positive numbers here and some negative numbers here. We will talk about this later in details. Okay, don't worry about this now. We will talk about this. Then we have another function called line space function. What does this do? So you have a starting number, you have an end number, No, not necessarily. So Bharti, not necessarily. You see this number, it is 1.75. Okay. Similarly, this is minus 2.81. We will talk about this. Don't worry now. We will talk about this. So we will talk about this today. After the break, we will talk about this in details. So that is part of the stats today. Okay. So now line space function, what does it do? It takes three inputs. One is the starting number, one is the end number, and then how many numbers do you want between this? Okay. So this is similar to the range function, where it will give you six numbers equally spaced between 1 to 20. Okay, this is what it means. So I have written it here: n evenly spaced points between start and stop. So if this is your start and this is your stop, and you have given n, it will give you n evenly spaced points between start and stop. So for example, 1 and 20 I have given, and I have given 6. So it starts from 1, then it gives you 4.8, then 8.6. So basically it will give you six numbers between 1 and 20, and the numbers will be separated equally. So 4.8 minus 1 is equal to 8.6 minus 4.8 is equal to 12.4 minus 8.6, and so on. Okay. So this is a question for you guys. Can you answer this now? Can you answer this in the message? Yes, guys, this is a question for you. Can you answer this? Tell me the answer for this one. Two questions here. The first print statement and the second print statement. What will you get? Can you answer in the chat box? So there are two print statements. I want you to answer me both of them. I have defined here A and B. Then I have written print A plus B. And then I have written np.array A plus np.array B. What would be the answer? Try. Okay, so most of you are correct. This will give you this as the answer. So remember, we discussed that if it is a list, and if you multiply it by 2, or if you add it to another list, it will just repeat it. So when you write A plus B and both A and B are lists, it will just give you 1 2 3 and 3 4 5. It will just print the other one behind it. Okay, because lists do not support broadcasting, so you cannot add element to element in a list, but you can do that in an array. So that is why when you add them after converting them to an array, you get 4, 5, 4, 6, and 8. But as a list, you will just get one behind the other. Okay. So did you understand this, Bala? Okay. Now I want you to answer this question. So just a minute, I'll get the question on screen. So I want you to answer this question. I'll tell you what is x and what is y. So this is your x and this is your y. Okay. This is your x and this is your y. So see, try to answer this, guys. You can use pen and paper if that helps you. Okay, I have to tell you that. Yeah. Okay, 1 second. So this is your A and B. 1, 2, 3 and 3, 4, 5. Okay. Yeah, now you should be able to answer. Don't use Python to do this. Use your pen and paper. Okay. Okay, so Anil has got -2, -2, -2. What about the others? Okay, so everybody has a different answer. None of your answers have matched so far. Okay, let's do this. Okay. So let's first see this. What does this mean? And then we will see this separately. Okay. So first I will write x 1 and then colon and I have left it blank. What does this blank mean? This means till the end, right? Till the end. So what is my x? My x is 1, 2 and 3. The index of this is 0, this is 1, this is 2. So this means I have to start from 1 till the end. That means what should I get? I will get 2 and 3. Right guys? I'll get 2 and 3 as the output of this. Okay. Similarly, I'll do for y now. Y starting from the beginning till -1. So what is my y? My y is 3, 4 and 5. And if I have to go by index, this is -1, this is -2, this is -3. Okay. But what does this mean? This means not till -1. This means till 1 less than -1. Right, guys? Remember, if you write y 2 is to 5, this means 2, 3 and 4, not 5. 5 is not included. It is always 1 less than this, what you write here. So that means it is not till -1. It is till 1 less than -1. That means it is only till here. So this means it is 3 and 4. This is the answer for this y. Now all you have to do, since these individual pieces are arrays, since I have converted them to array, it is like 2 minus 3 and 3 minus 4. So -1 -1. This is the answer. -1 -1. Did you understand now how you should do it? So I guess none of you got it right. Okay. So this is the answer. -1 -1. You leave it blank. Bharti, you leave it blank, you will get 5 also included. So instead of writing -1, don't write anything. Just write y. Just write y and you will get everything. Or just write y and give colon. Don't write starting and don't write ending. If you just write colon, means starting from the beginning till the end. Okay. So I'll have more examples in the homework, don't worry. You'll understand this, it's not very difficult. Okay, let me leave some things for homework. I'll have more examples on this in the homework. So do remember to practice it. Okay, so now let's conclude arrays by looking at the difference between arrays and lists. So this is what we have studied. Lists, they have same arrays, they have same data type versus multiple data types in lists. NumPy arrays support vectorized operation, which is nothing but another way of saying broadcasting. Arrays, they support vectorized operation, that is, it will give an error, Anil. If you have different lengths, it will give an error. Okay. So NumPy array support vectorized operation. Example, multiple element by a constant. List cannot do that. Okay. So these are the differences between a list and an array. Okay. So let us take a break at this point. Once we come back from break, we will start with, we just have two data types remaining. One is series and one is data frame. So data frame is the most important data structure used in machine learning. So we'll start with this after the break. Okay. So let's take a 10 minutes break. We will have the class till 12 today. So I'll give you another break after some time. So let's take 10 minutes break, 2 breaks of 10 minutes each. So it's 9:55 now. Let's be back by 10:05. Is that okay, guys? So we'll resume at 10:05. I'll see you guys then. So let us continue ahead now. So let's see the next data type, which is series. Okay. Now the next few data types that we will be looking at, they are present in the other library, which is Pandas. Okay. So now we are moving to a new library, Pandas. So same as we did for NumPy library, we will import Pandas and we will give a short code to it, which is PD. So this is the usual, this is usually the short code which everybody assigns to Pandas. So import Pandas as PD. Now what is a series? Let's see. So here I have defined two lists. There are two lists here. One is label and one is, let's say, data. Okay, let me give it some other name. Let me call it temp instead of data. Okay, so two lists I have defined here. Next, what I will be doing is I'll be converting this to a array. I have converted the list temp to an array by using the np.array function. So how would I define a series now? To define a series, I will use pandas.series function. Okay, so I will write pd.series, and then the next what you will write is, so pandas.series takes two inputs. One is the data. I will press shift tab and I will get this. So you see it takes two inputs. One is the data and one is label. So data and then index. So I'm talking about these two inputs. Okay, I cannot write on top of it. So one is data and one is index. Okay, so for data I will give this temp array or this ARR array which I just formed, and for index I will give the list which I had previously formed, which is label. Okay, so let's see what I get. So when I run this line is not needed. Okay, so when I run this I get something which looks like a two-dimensional thing. You have rows and columns. So what you have is, this is the data 10, 20 and 30. This is my data and it has indexes. Okay, it has indexes. So this is called a series. A series is very similar to an array. The only difference is that it will have labels additionally, or it will have indexes additionally. Okay, so it is similar to a array, but in addition to the data it will have indexes also. So this is the index. ABC here is the index. So index is like a serial number, for example roll number. So you have your names and corresponding to every name you have a roll number. So that roll number is the index, or you can say the primary key, something like that. Okay, so this is what is a series. We won't be using series maybe at all, but we need series to understand data frames. Okay, so now let us come to the final data structure and the most popular one. So you will always be working with data frames almost 90 to 95% of your times. Okay, so this is the most important data structure in Python, and this is also present in R. So a lot of you would have heard of the language R. So even there you have the concept of data frames, and it is the same as what you have in Python. There's no difference. Okay, so how do I define a data frame? I will use pandas.dataframe function. Okay, this is a function that I will use to define a data frame. Now what inputs go into a data frame? Three inputs that go into a data frame. The first input is the data that you want. Okay, so what data do you want in your data frame? I have given the ARR array which I formed here. So the array which I formed here, I have given that as an input. Okay, then data frames will also have indexes, just like series. They will also have index. As index I have given label. Label is here, and one additional item it will have apart from a series is that it will have column names also. Okay, it will have column names. So I have given, since I have only one column, this is just one column, I will give only one name here. So now if you look at the data frame, it looks like this. Okay, it looks like this. You have rows and you have columns. So this is your row. These individual three rows you have, and you have one column. This is the index. This is not a column, this is the index. Okay, so this is what is a data frame. So a data frame is like a SQL table. Okay, all of you know what is a SQL table. Data frame is like a SQL table. It will have rows and it will have columns. Only additional is it will have indexes. Okay, or a Excel spreadsheet you can say. Okay, each row will represent one particular entity, or let's say if you have students in a class, each row will correspond to properties of the students of an individual student. So first row might be for one student, so one column might be for student's first name, then second name, the age of the student, and so on. Okay, so each row will represent one particular student, and these columns will be the properties of that student. So it may be first name, last name, age, and so on. So I have just one column here. You may have several other columns also. Okay, so for example, this is a data frame. This is a data frame which has 4 columns and it has 5 rows. So each A, B, C, for example, these are individual students, and these are some values for those for the same student. Are you following, guys? Yeah. So a data frame is like a two-dimensional SQL table, okay, or it is like a Excel spreadsheet. Okay, it will have rows and it will have columns. So let me show here. So we are talking about data frames. Okay, so a data frame will have columns, it will have indexes, and of course it will have data, right? So let's see. So columns, let's say I will write name, I will write age, I will write, let's say, income, and so on. Let's say this is just serial number I have given. So let's say name is whatever name you want to give. Okay, so what is this? This is a data frame which has 3 columns. Okay, this is a data frame which has 3 columns. The first column is name, second column is age, third column is income. Okay, and what is this? This is not a column, this is index. Okay, this is different than a column. So right now I have serial number as the index, but you can also have something else as an index. You can have the name of the person also as an index, but right now I have serial number as index. Okay, so each row represents one person. So each row here represents one person. Similarly, each column represents one property. Okay, so this is the name, this is the age, this is the income, and so on. Now do you understand, Vikram? So this is a data frame. Let's say this is DF. Okay, I'm calling it DF, short for data frame. Okay, now how do we access individual columns? Let's say if this is a data frame and I want you to print me all the names of all the students, names of all the students. If I want you to print me the names of all the students, how would you do that? So the way to access individual columns in a data frame is you write the name of the data frame. Let's say DF is the name of this data frame. So you write the name of the data frame and then you give a square bracket, and then within quotes you write the name of the column. So if you write name like this, what you will get is you will get Rajesh, Raju, Vinod, etc. Okay, this is how you access individual column from a data frame. Okay, similarly if you have to access income, you will write data frame and income. This way you will get this entire row, this entire column. Okay, this is how you access columns in a data frame, by using the column name. Since you have names for each column, you can use that name to access the column. So this is what I have done here. I have used data frame dot column name, and I am getting 10, 20, and 30. Okay, the indexes will always appear. This is like fixed to the data, so they will always appear. Okay, I can also use data frame dot column name, but this is not popularly used. We usually use this. Okay, so don't worry about this, just use this. But you can use this also. Just write data frame dot the column name, or you can use this. Okay, let me run this. So you can use Python's IntelliSense to access columns. Let's say I write data frame, and if I start writing col, so this is the column name, right? If I start writing col, oops, so I'll use a quotes, and then I start writing col, and if I just press tab, you see I'm getting some options. Okay, I press tab and I'm getting some options. So Python's IntelliSense is helping me. So it is telling me that col1 is the name of the column, and I just press enter, and I can automatically fill it. So you don't have to write the entire column name. Just write the initials and press tab, you will get the option. So you can use that. Okay, and if you see the type of one column, let's say if I see the type of this, what you get is a series. Okay, so what does this mean? This means that each column in a data frame is a series. Okay, so this is a series, this is a series, this is a series. And what is a data frame? A data frame is just combination of series. Okay, so each of these is series 1, series 2, series 3, series 4. Each of these are series, and all the series, they have the same index. So this is what you'll have to remember. The index should be the same for all the series, otherwise they will not be together, right? If each of them have a different index, they won't be together. So for example, here series name has the index 1 2 3, series age has the index 1 2 3, series income also has the index 1 2 and 3. So it was easy to bring them together as one data frame. So that is what is a data frame. It is a combination of series. Okay, it is a combination of series put together. Let's see another example. So now I'll form a data frame with multiple columns. So I will use the same pd.data frame, and data is equal to, I have written np.array. So I have created an array with 4 elements, 1 2 3 4, and immediately after it I am writing dot reshape also. So what does this mean? This means that it will convert this data to 2-dimensional with 1 and 2 at the first row and 3 and 4 at the second row. So this is what I will get. And then I have written columns is equal to A and B. Now notice this, I have used double square brackets. Why double square brackets? Because I have to pass column as a list. Here I had just one column. Here I had just one column, so I wrote it directly. But if you have more than one column, you will have to pass it as a list. So that's what I'm doing. I'm passing it as a list, and one of the square bracket is mandatory, that is syntax. But within that I am passing multiple columns, so I have to pass it as a list. So if you do that, you will get this as the data frame. This is the data frame. Now notice I did not give the index function here. I did not use the index function, but still I am getting 0 and 1. So this is by default. By default it will give you 0 and 1 as the index. Here I had used index function, but here I had not used 0 and 1. I had given some particular value a, b and c. That is why I used index is equal to label. But if you don't give this, Python will by default give 0 1 serial numbers to it. So whatever I have written here, it will start from 0 and it will give serial number. That will be the index, the default index. Okay, is that clear, guys? Are you following? We will see more examples of this. So we can form an empty data frame using this. You just write pd.dataframe and just open close the braces. It will be an empty data frame. Okay. Next, again, some more examples. I'm forming some data frames here. So okay, so whatever I told here, guys, passing this double square brackets, this is not mandatory. Okay, it is not mandatory to give double square brackets. See here, I have given first only one square bracket, and this also works. So it is not mandatory to give double square brackets. So that is good. You will not confuse there. You use a single square bracket rather. So let me remove this. This is not required. Okay, this should also work. Yeah, this is also working. So one bracket is enough. Okay, so again, what am I doing is what am I doing? I'm just creating a data frame here. So I have created a list which has 3 rows, array which has 3 rows. So this is an array which has 3 rows. The first row is Alex 10, second row is 312, third row is Clark and 13. And then I'm using this, I'm passing this, this itself is data, and I'm passing that data in the data frame, and columns I'm giving name and age. So what am I getting is this. Okay, so this is the same as before. Let's see something else. So this is again another data frame that I have created. Now here, what have I given? An additional argument I have given here. So if you see shift tab, if you see, there are many arguments here. So you have data, you have index, you have columns, you have d type also. What is this d type? This d type means what is the data type you want to define. Do you want any particular data type to your columns? Okay, so let's see. So the explanation for each of them is here. So data, this is the explanation. Index, this is the explanation. D type means data type to force. Okay, that means it will force that column to have that particular data type if you write something here. So let's see, what am I doing here? I have given 10, 12 and 13, right? So these are all integers, but here I have written data type is equal to float. So what happens as a result of this? Each of the numbers are forcibly converted to floating numbers. You see, these decimal numbers are given. So each data type or each of these numbers, the second column, is forced to be a floating number. So if I remove this and if I run, they will just be integers. See, they are just integers. But if I write data type is equal to float, they will be forced to be integers because that is what I have given as an input. Okay, so this is what d type is used for. Sometimes later we will see, when we start with case studies, you will want your column to be of a certain data type, or let's say you want to round off values. You have floating numbers but you want to round them off, then you just write d type is equal to int. It will automatically round it off, or just take the integer part of the floating number. Okay, now similarly you can form data frame from a dictionary also. Remember dictionaries that we covered yesterday? So I have defined a dictionary here which has two key value pairs. The first key is name and the first value is this entire big list. The second key is age and the second value is this list. And what I have to do is I'll just write pd.dataframe as before, and I will give this data. I'll pass this data inside, and data type I have given as float. No, only columns which are possible. It cannot convert this name to floating number, right? So it will convert only the age to floating number. Amit. Okay, it cannot convert this column to floating number because these are all characters, but this one it can convert. So it will convert only columns which is possible to, otherwise it will not. Okay, so here also that's what it is doing. You have Tom 28, Jack 34 and so on. If you want, you can give some index also. This is the same example as previous, but I have given some index. So I'm getting rank 1, rank 2, and so on as indexes here. So these two are same examples, but one has index, the other doesn't have index. Okay. Now let's say you have a data frame and you want to delete a column from a data frame. Okay. So data frame is what we'll be looking at in details because we will use a data frame a lot. So let's say you want to delete the age column from a data frame. So how will you delete? You can just use the drop function. Okay. So how is the syntax? The syntax is data frame dot drop, and then you write the name of the column that you want to delete. Okay. And then you write access is equal to 1. What is access is equal to 1? Access is equal to 1 means you want to delete a column. Okay. So access is 0 for rows and it is 1 for columns. So how would Python know whether this age is a row or a column? So that it knows by when you give the command access. Access is equal to 0 means you are deleting a row. Access is equal to 1 means you are deleting a column. So the moment you write access is equal to 1, Python will search in the columns and it will find that okay, there is a column called age, I'll delete it, and it will delete that. So you see now you just have name. The column age is deleted. Okay. But when you do this, you are not overwriting your data frame. Okay, this is just deleting and printing it. You are not overwriting your data frame. So if you want to overwrite your data frame, you write df is equal to this quantity, then it will overwrite. Okay, or in other words, what you can do, you can write in place is equal to true here. You can just write in place is equal to true. This will also overwrite. Okay, so either use in place is equal to true, or at the beginning you use df is equal to this new thing, so that it will overwrite. Otherwise it will just print on the screen, it will not delete in the original data frame. Okay, so without in place is equal to true, it just prints the result, but it will not overwrite the original data frame. Yes, Amit, it is applicable. So all these codes that I have right now, these are all actually 2.7 codes, but they work in 3.5 also. So far there is no change between 2.7 and 3.5. Even I updated my Python only 2 days ago. I was using 2.7 all this while from the last 3-4 years. Only day before yesterday I updated it to 3.5. Okay, so far there is no change. So the access it works, or the in place it works in both the versions. Okay, now similarly I'm forming another data frame here. I'm using the random function. Remember this random function, what this would give me is, it would give me 20 random numbers in rows of 5 and columns of 4. So it will give me 5 rows and 4 columns, that many random numbers. Okay, from a uniform distribution, between 0 and 1. So this function we saw earlier, and I have given index as abcde dot split. So we already saw what split function does. The split function will just split it into individual letters a, b, c, d, e. So that's what I have here as index. Okay, and my columns are w, x, y, z dot split. Okay, so if I do this, I get this as the data frame. Okay, so have you followed so far, guys? Data frame. First, do you have any questions? You have raised your hand. Yeah, we will come to that, Amit. Don't worry about that. Harsh, you are not able to hear me? Yeah, I think it's your system issue. Others can. So don't worry about where these things will be used. Okay, guys, this is the second day of your class. We have an entire course pending. So we will start using it later. Okay, so don't ask that question right now. You will get your answers soon. Okay, so whenever you analyze data, your data will be in terms of a data frame. So that's where you will be using. Any data that you read, it will be as a data frame because you will have rows and columns. A SQL table, what does it have? It has rows and columns. That is a data frame. A SQL table is nothing but a data frame. In SQL, it is known as table. In R or Python, it will be known as data frame. Okay. Yes, of course, Anil. It can hold null values also. We will see that. Okay. So that will come under data manipulation. So look at this. Look at this data frame. So you have a data frame here which has null values, NaN. Okay. So that will come under data manipulation. We will come to that. Okay. Now we have seen how do we access individual columns from a data frame, right? Let us see how do we access columns and rows also from a data frame. This is also important. We should know exactly how to access individual elements from a data frame via the rows or via columns. Okay. So let's say if you want to access multiple rows. So this is our data frame. I have this as my data frame. I want to access multiple rows. I want to access, let's say, W and X, both of them, not the others, only these two. So what will I do? I will just write W and Z or whichever column I want to access. I will pass that as a list. So here I will have to use double square brackets because I'm trying to access multiple columns. Okay. So if I run this, okay, I did not run this. Let me run this first. So if I run this, I get W and Z as my output. Now notice if I just give first bracket, if I don't pass the columns that I want as a list, it will give me an error. So it gives me a error and it will say key error W and Z. So it was not able to find. Okay. So if you are trying to access multiple columns, you will have to pass all the columns that you are trying to access as a list. Okay. So as a list, you will have to pass. So now it will work. I have passed it as a list. So this first square bracket is mandatory. So the syntax of accessing column is you write data frame and then first square brackets and then columns you want. If you want just one column, you can directly write name of column, let's say C1. But if you want more than one column, then you will have to pass that as a list. Okay, as a list, let's say C1, then C2, and so on. So this is mandatory because this is the syntax. But if you want more than one, you will have to pass that as a group, as a collection, as a list. You cannot pass separately. Okay, so remember this. It has to be double square brackets. If you want to create new columns in your data frame, just write a new name, and let's say if you want to add two columns and create a new column, you just write data frame and give a new name and write to existing columns and you can add. So see, I have created a new column here which is just sum of W and Y. So 0.21 plus 0.56 is what is given here. So this is creating a new column in your data frame. Now once again I am trying to delete some columns from my data frame. So let's say whatever I created, this new column that I created, I'll delete it. So I'll use data frame.drop function. I'll write the name of the column, and then access is equal to 1 because I'm trying to delete column, and then I'll write in place is equal to true. This means it will be overwritten. So this new will be deleted permanently from my data frame. So next time if I print it, I get the data frame without this column new. Okay, this is how you delete columns from a data frame. Okay, now data frames also have indexes in rows and columns. Okay, just like you have in arrays and you have in lists, data frames, they also have indexes. So the index of the first column is 0, second column is 1, third column is 2. Similarly, index of the first row is, so here it is 1, here it is 2, here it is 3. By default it will have actually 0, it will have 1, it will have 2. So these are the column indexes, okay, and these are the row indexes. Okay, so now let us see how do you access individual elements or individual rows or columns from a data frame using the index. Using index, how can you use? So I can write data frame dot iloc is used for it. Okay, so what does this iloc means? Iloc means you are trying to access data frame using indexes. Okay, I for indexes. So how does it work? In the same way we saw earlier, you give the row indexes and then you give the column indexes. So that means if I write data frame dot iloc 2 comma 3, what does this mean? This means I want the row which is at index 2, I want the column which is at index 3. Okay, are you following, guys? This is, we have seen this earlier. The only addition is we'll have to use iloc function. Okay, we will have to use this iloc function. So for example, I have, look at the second example here. I have given, this is my data frame. I have given data frame dot iloc of 2. So just 2 I have given. What does this mean? This means I want the entire second row, or row which is at index 2. So which row is at index 2? The row at index 2 is this, right? So I will get this row as the output. See, I'm getting this row as output, 0.89, 0.91. So this row, this is the second one. Okay, so I'm getting this row, this is the output. It is coming from this. Okay, this one. Similarly, I can give both rows and columns also. I can give data frame dot iloc. Okay, I can give, let's say, 2 comma 4. This means I want the row which is at index 2, which is this row, and I want the column which is at index 4. So this is 0, 1, 2, 3. I don't have anything at index 4. So what will I get when I run this? I get nothing. Is out of bounds. What does this mean? This means that either the row that I have written or the column that I have written is not present in the data frame df. Okay, so it is wrong, and it is wrong, right? You see there are only, so the index starts from 0, so it reaches only till 3. This is 0, this is 1, this is 2, this is 3. So the index 4 for columns does not exist. Okay, but what I have done here is I have given index of 4. I have given index of 4. So it is telling me it is out of bounds. It is not existing. So let me use 1 then. Now if I run this, I will get the third row and the second column. Okay, so third row and second column, so 0.913. Third row and the second column, 0.79. Something is wrong. Okay, 0.79, third row and the second column, 0, 1, 2. Okay, yeah, this one. This is the data frame we are using, right? So I did not run the previous lines. Let me run this. Okay. Yeah, so 0.30 is what I'm getting. Third row and second column. So third row and second column. So 0.30. And this is what I'm getting here. Okay. So this is how you use the iloc function. Now another way to access is not by using index but by using the names. So your rows might also have a name, right? So right now we use the index, which is the serial number. But what if your rows has some index? Let's say it has index A, B, and C. It has some labels. Then how will you access the rows? Then you will use data frame dot loc, not iloc. I is used when you're using indexes, which is serial number. Okay. Loc is used when you are using the name of the row or the name of the column. So right now let's say B is the name of my second row, so I can write B here. And let's say age is the name of my second column, so I can write age here within quotes. So this will give me 28, because 28 is what is in my second row and age column. Okay, so for that I will use loc function, not iloc. Iloc is used for index. Loc is used when you access names. Okay, so that's what I have written here. Use loc if you want to access by row label, row or column label. You can give column also here. Okay, so just like I use this, I can also use instead of iloc, I'll just like loc. But if I write loc, I'll have to use the label. I cannot use the index. So I'll use, let's say, A, and I will use X. Now this will give me, okay, I forgot to close the square bracket here. I should close it. Then if I use, it will give me 0.84, which is the data in row A and column X. So row A and column X is 841. So I'm getting 841. Okay, so this is how you use the iloc function or the loc function. Loc function when you want to access a data frame using the label or the index, okay, and the column names. And iloc you want to use when you want to use serial number. So this has a serial number 0, 1, 2. Similarly this also has 0, 1, 2. So if you want to use these numbers, you use iloc. But if you want to use the names ABCD or XYZ, you will use just LOC. Okay, is that clear, guys? Okay. Now you can give conditions also into a data frame. Let's say if you want to filter a data frame based on a condition. Okay, so let's say you have a data frame. You have a data frame like this, where you have employee ID, you have name of the employee, you have, let's say, salary of the employee, and you have his department. Okay, so let's say 101, you have some name, some salary, and let's say HR. You have 102B, you have, let's say, finance, and so on. Okay, now if you want to filter out, some data from this, let's say you only want employees from the HR department. So imagine this data is a long data. Let's say it has 1001. It has some XX, Y, 15. Let's say this is also HR. So if you want to filter out only people who work in HR department, or you want to know the employee ID of everybody who works in HR department, how will you do that? You will write name of the data frame, and then you will have to put a condition on this column, right? On this column you have to put a condition. So how will you do that? You will first access that column. How will you access that column? By using this. We already saw this. We will write the name of the data frame and then the name of the column. So this way we will access the column, and then we will write is equal to HR. Okay, and we'll put everything in square bracket. So this is how you will get only 101 and dot 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 till 1001. Okay, because only these people work in HR department. So double equal to you will use because you are checking, you are not assigning. Single equal to is used for assigning something, x is equal to 5, but double equal to is used when you want to check for a condition. So here I am checking for a condition that only give me details of those employee who belong to the HR department. Do you follow this, guys? Similarly, I can have multiple conditions also here based on my requirement. If I have multiple conditions, I can write one condition here and another condition here, all within square bracket. Or I can write one condition here and give the or and another condition here. Okay, so this can be, for example, data frame. Let's say salary is greater than 10, and data frame once again salary is less than 20. So this will give me all employees whose salary is between 10 and 20. Okay, not required. It will give me all the columns. Okay, so Vikram, it will give me all the columns. Since I have not specified any column, it will give me all the columns as the output. So for example, when I run this, see, I ran this data frame. Okay, here I have not used any column here. Okay, I have not used any column. I just gave a condition on the entire data frame. So what will I get? I will get all the values which are greater than 0, and in this data frame all the values are greater than 0. So I get everything. Basically I get everything. But if you see here, I have given data frame W is greater than 0. So only those values from column W will be selected which are greater than 0. Again, everything is greater than 0, so I get everything. Let me write let me write here some other number. Let me write 0.5. Okay, now let's see what happens. What do I get? I get only those rows for which W is greater than 0.5. So notice this carefully, guys. So I'm applying a condition on W, so this column. So which values are greater than 0.5? This is greater than 0.5, this one is greater than 0.5, and this one also. So I have only A, C and D in my output because only these three rows satisfy that condition. But which columns do I have? I have all the columns, since I did not specify anything, right? I did not specify anything, so I have all the columns printed. Okay, do you follow this? But let's say you don't want all the columns, you want only a few columns to be printed. So you can do that also. If you want only a few columns to be printed, after this you write those few columns. Let's say you want only X to be printed, so you write just X. So if you write X here, see, now only X is getting printed from A, C and D. So two things are happening here. First, only those rows are getting selected which are true for this condition. Okay, so only row A, C and D is true for this condition, but not all columns are getting printed because you have given X here. You have given X, which means only column X will get printed. So you will have 0.84, 0.30 and 0.86. Do you follow this now? Look at these two examples and see if you understand. Similarly, if I want multiple, let's say I want X and Z both, I will write X and Z. Okay, I'll have to pass as double square bracket. Okay, this will give me both X and Z because I have written X and Z both, and I am passing that as a list. Okay, I have to pass that as a list. Remember this. Okay, so this itself is like a data frame, a smaller data frame. Okay, so it is like if you break the problem into smaller pieces, what will you understand? No, you have to. This entire thing is a data frame. Arpita, you are not noticing it carefully. See, you have this data frame, okay? So notice this carefully, guys. There is a catch here. So you have this data frame. This is your data frame. When you write data frame dollar department is equal to HR. Okay. Now this itself is a data frame. Let's say this is DF dash, right? This is DF dash. Now you can write DF dash and you can write, let's say, EMPID, right? This is allowed, right? This is how you write. You write the name of the data frame and the column that you want to extract. Now instead of DF dash, I'm writing this entire thing. Okay, that is what I'm doing. Instead of writing DF dash, what am I doing? I'm writing DF department is equal to HR, then closing it and then writing EMPID. So look at this. What did I do here? I have just used a short code. Instead of first putting it into df dash and then using that df dash here, I am directly putting this entire thing here and then using the column name. Do you follow this? Okay, so as you do more examples on this, these things will become clear, guys. So these are not difficult, these are very easy things. As you start doing more and more, things will become clear. So similarly, I have used multiple conditions here. I have given two conditions. This is my first condition, and then I have used the AND notation and given a second condition. Similarly, you can use this parallel bar for OR condition. Okay, so I think this is all that you need to know about data frame. Later, as we go ahead, we will practice more and more, and you will start learning more about data frames. Okay, but for now, I think this is enough. Now we can move to data manipulation. So any doubts so far, guys? Tell me. Are you following? I know you will require a little practice before you become comfortable, but are you at least following it? Harsh, you have a question? You have raised your hand. Difference between drop and access. No, they are entirely different things, Harsh. They are not at all the same. Okay. So drop is used to delete a column. Yes, Arun, it will take some time. So after you start practicing, you will get used to it. Okay. So Harsh is asking the difference between drop and access. Okay. So when you write data frame, yeah, we will talk about that, Arpita. That also comes under data manipulation. Okay. So we have here merging. Okay, how to merge two data frames. Okay, so Hers is asking what is the difference between drop and access. Hers, whenever you write data frame dot drop and you write, let's say, name of a column, let's say I want to delete department. Okay, now when you write this, how will Python know whether you are trying to delete a row or you are trying to delete a column? Okay, so to tell Python that you are trying to delete a column and not row, you write access is equal to 1. If you don't write access is equal to 1, Python will not know whether you are trying to delete a row or a column. It cannot search at all the columns and at all the rows to find where is this department. So access is how you tell Python that okay, access is equal to 1 means I'm referring to a column. So Python will search along the columns and see if this department exists there. If it exists, it will delete. Similarly, if you write access as 0, it will search along the row and see if the word department exists along the row. If it exists, it will delete. Okay, do you follow now what is drop and what is access? Okay. Yes, access is always used with drop. Okay, so it has a default value of 0. So if you don't give any value of access, by default it means 0. But it's always good to use, otherwise you might not remember that the default value is 0 or is it 1. So it's always better to use 1 or 0 directly yourself. Okay, so before we move to any data manipulation, let me talk about a little bit of visualization, because this is easy. So you'll not require a lot of focus here. So let us quickly finish some basic visualizations in Python. Okay, so the first library that we'll be using for visualization is the matplotlib library. Okay, matplotlib library is very popularly used for visualization, and you can draw almost any kind of a chart using matplotlib. Okay, so I'll be covering the very basic charts that is most popularly used, but you can draw a lot of other charts also using matplotlib. I will strongly suggest you guys to Google matplotlib and go to the official page of matplotlib. You will find a lot of charts. Okay, not all will be required, and of course you can come back to this page as and when required, but there are thousands of charts here. Okay, so you go to examples and you will see that there are thousands of charts, and codes are also available for each of the chart. So you see these charts, thousands of charts are there, and for each chart you have the codes available. All you have to do is just click on the chart. So thousands of charts. Okay, so let's say you want a pie chart, just click on this pie chart and you will get the codes for it. Just copy paste the codes and change the data. That is what you have to do. You don't have to remember every line of code that is used here. Just see this is the code, not a long code, very small piece of code. Okay, and you get this kind of a chart. Okay, so check this site. I'll share you the link for this. This is the link. Okay, this is matplotlib. I'll cover the basic charts that we'll be using. Okay, that is used very popularly, but sometimes under special circumstances you might require one of these complex charts. So then you will have to look for codes here on this website. Okay, so let's first load the library. So we will load the library first. So I will write import matplotlib.pyplot as plt. Now you see this is the name of the library. It is quite big. So I have given a short code to it, which is PLT. So I'll be using PLT from now onwards. Wherever I use PLT, it means that it is coming from the matplotlib library. Okay, I have also imported pandas. Okay, it takes a while to load. So until you see this star sign, it means the code is still running. Okay, if you see this star sign here, that means the code is still running. So once it is gone, means it has run already. So it has run now. Okay, it has loaded it. So I can proceed now. So I have imported matplotlib as PLT. And what is this? What this means that you will be able to see the plots within the Jupyter notebook. If you want to see your plots within the Jupyter notebook, you have to use this. If you don't use this, you will not be able to see the plots. Okay, so to see a plot within the notebook, you have to use this. Okay, now Sijo, have you logged in using multiple devices? Okay, I see two names here. I see two names for you. Okay guys, please don't log in using multiple devices. So later when the class is full and if you log in using two devices, that means somebody else will not be able to enter. So only log in using one device. You can use your mobile or your laptop, but only one at a time. Right now it is okay because we have only 16 so far, but try to avoid that. Okay, okay, no problem. Okay, so this is how it is. Sorry guys, there was somebody at my door. Okay, so I have loaded this now. Now I have just created a simple, I have imported the numpy function as well. And remember this line space function that we used earlier. I have used the line space function. So what does this do? It will give me 11 numbers, 11 equally spaced numbers between 0 and 5. Okay, so this function will give me 11 equally spaced numbers between 0 and 5, and next I am just printing them. So when I print them, this is what I get. Okay, this is what I get. Now let's draw a very basic chart. So I'll draw a very basic two-dimensional chart. So this is different than a histogram because this is two-dimensional. I have two variables. I have one x variable, I have one y variable. Okay, so how have I drawn this? I have just used plt.plot. So see, this is so simple. I have just used plt. What is plt? plt is coming from here. Okay, and then I have used plt.plot. Then what do you want on your x-axis? So my x is this, and my y is nothing but the same numbers multiplied by 2. Okay, oh sorry, same numbers to the power 2. Double star means to the power. Okay, so 0 to the power 0 is 0. 0.5 to the power 2 is 0.25. So plt.plot x, y, and this is my r. So this r stands for red color. That is why I'm getting this in red color. Okay, and this is just the label I'm giving. So plt.x label is my x-axis. So I have my x-axis here. Okay, you can write any name you want here. So if you just write x-axis, if you just write y-axis, you will get, okay, my x and y is not defined, I didn't run this, you will get this. Okay, so you have x-axis here, you have y-axis here, and this is your title. So whatever title you give here, that will appear on the image. So this is how you draw a basic plot. Okay, now this is a line plot because the points are connected by a line. Okay, you can see the points are connected by a line. If you don't want them to connect them by a line, you can use plt.scatter function and the same syntax. So here the points will not be connected, you will see the dots. Okay, so for example, the first point is 0 0, so that is what you see here. Okay, the first point, it is 0 0. Okay, similarly the other points, the next point is 0.5 and 0.25, so the next point is this one, 0.5 and 0.25, and so on. So this is a scatter plot where my points are not connected by a line. This is a line plot, this is a scatter plot. Okay, and now we come to our histogram. So this is the histogram that we learned yesterday. Okay, this is how you draw a histogram. So how my first I'm just creating some random data just to draw the histogram. I need some data, right? So from the random function, I have just the sample function. What will it do? The sample function will just pick randomly from a big list. So what is my big list? My big list is this range function. So range from 1 to 1000, it will give me numbers from starting from 1 till 999. Okay, now from those 999 numbers, I am selecting 100 numbers randomly. Okay, so this sample function does that. It will pick as many numbers as you specify from a bigger list of numbers. So my bigger list of numbers here is from 1 till 999, and I am picking 100 numbers from that list. Okay, and then I am using plt.hist function. So hist is used to draw a histogram, very easy to remember. And then you give what is your data, on which data do you want to draw, and this bins, remember this bins is those ranges that you create. Okay, so if I run this, I get this as the histogram. I can increase the bins, I can increase it to let's say 40, then I will get even more granular data. So now the data looks more granular. I can make it let's say 70, then it will become even more granular. So thinner bars I will get. Okay, let me make it 30 itself. Yeah, it is plt.scatter, Bharti. So for scatter plot you use plt.scatter. For histogram you use plt.hist. So it is very easy to remember. If you want a histogram, just use plt.hist. If you want a scatter plot, use plt.scatter. Actually, you don't have to remember. You can use Python's IntelliSense. So you just write plt dot and press tab. You see, you get so many options. Okay, you have so many options. So if you write hist, you will get so many options. Okay, so hist is there and so many others are there. If you write s, you get so many options. Scatter is one of them. Okay, so you can use IntelliSense and you can remember. So this is how you draw a histogram for any variable. So this can be any variable of your data frame also. So how would you draw histogram? So let's say you want to draw histogram for the salary. So what would be the syntax? Can somebody tell me? How will you draw the histogram for everybody's salary in a company? So you will write plt.hist and then you will write data frame and then salary, right? This is how you will write. This is your data and this is the normal function. Okay, if this is your data frame which has the column name salary, you cannot directly write salary because Python will not know what is salary. So you will have to write the name of the data frame and then the column name. Then the Python will know that okay, this is a column in this data frame. Otherwise Python will not know. It will throw error. Not important, but if you don't give semicolon, let's say I don't give semicolon, let's see what do I get. If I don't give semicolon, I'll get these data also available here. So Python will show me the data points, the ranges and everything. So it kind of looks dirty. So to avoid that, I give a semicolon. Then it will not show me that. It will directly show me the plot. Okay. So no big region. Now similarly, we have another kind of plot. This is for a box plot. We will talk about this later. So I'll talk about what a box plot is after some time. But this is the link which I shared already with you. This is the link to the official page of Matplotlib. Okay. So whenever you need some kind of a plot, you can always look here. You'll find the codes also. Now one example is shown here. This is, let's say, one data. So here I'm reading data from a website. Okay. So how do you read data from a website? So at this website, if you see, there is a CSV file at this website. At this URL, there is a CSV file. A CSV file is a comma separated file, just like an Excel file, where different columns are separated by comma. Okay. So I'm reading. How do I read a CSV file in Python? I will use pandas.read_CSV function. Okay. So this is the function that is used to read a CSV file. And notice this, you will have to give the entire location of the file. If this file is on the internet, you will have to give the entire URL, or if this file is in your local system, you will have to give the full location of the file. Okay. So right now it is on the internet, so I have given the entire URL. Now the file looks like this. So what is this head function? Head function, what it will do, it will show you top 5 columns of your data frame. Okay. It will show you the top 5 column. Head means the top 5. Similarly, you have tail column also. Tail function will show you the bottom 5. As the name suggests, tail function will show you the bottom 5. Okay, let me run this first. Okay, it is showing me the bottom 5. You see the indexes changed. So this data has 200 rows. Head function will show me the top 5 rows. Tail will show me the last 5 rows. Okay, that's the head and tail function. Now if I want to draw scatter plot, so what do we have in this data? We have the marketing budget of a company. So how much did the company spend on TV marketing, on radio ads, on newspaper ads? And this is the total sales of the company. How much total sales did the company have? Okay, so sales is in millions of dollars, and this is in thousands of dollars. Okay, so the units are different. Don't think that they have spent 38 units on TV and they only got a sales of 7.6 units, so they are spending more than they are selling. No, this is in thousands and this is in millions. So let's say if I want to draw a scatter plot between sales and these 3 variables. So I want to draw a scatter plot between sales and each of these 3 variables, so that I can see which is influencing my sales more. Is marketing on TV or radio or newspaper, which of these is influencing my sales? So I want it in the same scatter plot. Okay. So what I will do, I will divide my scatter plot into something called subplots. So for that I will use plt.subplots, and then this one represents, I'm dividing my space into 1 row and 3 columns. So that is what I have here, right? I have 1 row, this is like 1 row, and I have 3 columns. So this is the first column, second column, and third column, and in each column I have one plot. So that's what I have done here. Share is equal to true means each of them will share the same y-axis. So you see only this has the y-axis, this does not have, because all of them, they have the same y-axis. So I have given shared y is equal to true. I can give this false also, then each of them will have their individual y-axis if I write false here. And then I'm drawing the plot. So I just write data.plot. What kind of plot do I want? I want a scatter plot, and this is my x-axis, this is my y-axis, and I have given 0, 1 and 2. 0 means this will be my first plot, it will come here. 1 means this will be my second plot, so it will be in the middle. 2 means this will be my third plot, it will be here. And this is just the dimension. So 20 centimeters wide and 8 centimeters tall. Centimeters or maybe it is in, yeah, I think it is in centimeters only. Okay, if I give a smaller value, it will look smaller. So don't worry about this code. You don't have to remember this. Even I don't remember this code. Whenever you need, you can always Google and get this done. Okay, so you don't have to remember this, but just understand the syntax. What you are doing, you are taking your space and dividing it into 3 parts, so 1 row and 3 columns, and in each space you are drawing one chart, one small chart, and then based on this you can decide which is influencing your sales more. So what do you think, looking at these 3 data, which is influencing your sales more? Is it marketing in TV, radio, or newspaper? Yes, so Bharti is right. Your TV is influencing your sales more. Okay. Arpita, why can't you plot? Even if the units are different, doesn't matter, because you are plotting them on 2 different axes. So the units doesn't matter. So for example, if I ask you to plot the income versus age of a company, of the employees of a company. Let's say if I ask you to plot the income and the age of people in a company. So you can always plot this, right? They also have different units. Income is in rupees, and age is in years. So can't you plot them? For scatter plot, they need not be in the same unit. Okay, they can be in different units. So yeah, this probably tells you that TV is helping you grow the sales more than the others. Okay, so you see the line is, the slope is higher here. So we will of course go into the details once we start with machine learning. So this is what linear regression does. Okay, so we will study this in details, but this is just by looking at the chart also we get an idea that your marketing in TV is helping you more than in the others. So this is the information that you get from these plots. So we will talk about box plot in a while. So this we will talk about. So the syntax is simple. You just write plt.boxplot and you get this kind of a plot. So we'll talk about this. Okay. Now similar to matplotlib, there is another library which is called the Seaborn library. Okay. This is also very popularly used for plotting different charts. And this also has a page. So if I take you to Seaborn, so here also you have a lot of visualizations. So if I take you to gallery, you will see this also has thousands of plots. Okay, this also has many plots. Whichever you want to plot, you can click on it and you will get the codes for it. So let's say if I want to plot this one, so you will have some questions in the assignment where you will have to go to these kind of websites and you'll have to Google and do the assignments. Okay, you can of course ask in the WhatsApp group if you have any doubts. So see, this is the code for it. Not very long, just some 7-8 lines. All you have to do is change the data. So see, for example, here they are doing on some data. You just will have to change the data and you will get the plot. You'll get a similar plot for your own data. So just changing the data is what is required. You don't have to remember all these codes. Nobody does. Okay, so don't think that how will I remember these codes. Nobody remembers. I have been using these for 3 or 4 years. I never remember this. Whenever I need them, I just go to Google, I copy paste, change the data. That's it. But you should know how to change the data, where to change the data. That you should know. Codes, it's okay. No need to remember the codes. The basic syntax and all you should remember, but so you should know what is this random function doing, what is this pd.data frame. All this we have seen already. Okay, so let's quickly walk through Seaborn. I'll not walk through all the points given here. Okay, this is a exhaustive list, so it's very easy. You can just explore them on your own. I'll just walk you through the basic ones. Okay, so first I will import the library. So similar way, I'll give a short code to the Seaborn library. So import Seaborn as SNS. This is what is commonly used. Okay, SNS. So even if you see here, they would have used SNS only. So SNS they have also used. Import Seaborn as SNS, import Pandas as PD, import numpy as NP. Okay, and then here, so SNS library itself has a data set. Okay, it has a data set called tips. Okay, which is basically on how much tip do people give when they go to a restaurant. Okay, so let's read the data. So this star means it is still running, so we will wait for it to complete. Okay, so this is done. No, this, so I already explained this entire piece of code. So Bharti, this entire piece of code means that you will get the plot within the Jupyter notebook. If you don't use this code, you will not get the plot within the notebook. So this both represents the same thing. Okay, it is part of this. It is not separate. But there is no meaning of this. It is just used so that you get the plots in the same notebook. Okay, so this is how my data set looks like. I have the total bill. What was the total bill of that person or that group which went to the restaurant? How much tip did they pay? What was the gender of the person who paid the bill? Whether they were smokers or not. So this is basically from a pub where people are also smoking. Then which day was it? So which day of the week was it? What was the time? Was it a dinner bill or was it a lunch bill or a breakfast bill? And what was the size of the group? Okay, so these many details you have on the data frame. This is the data frame. I've used the tail function, so it is showing me the last few rows, last 5 rows. Now the first plot that we will see in Seaborn is called dist plot. Dist plot is nothing but a histogram. In Seaborn they have given it a different name. So remember, histogram is used to see the distribution of a variable, right? So it is also known as a distribution plot, dist plot in short. So how do I draw that? I will just write sns.distplot. This is the function. And then I will write on which column do I want to draw this. So data frame, then the column name. So let's draw this on the total bill to see how is total bill distributed. So we get this plot. So what does this tell me? This tells me that most of the people they paid a tip of around between 10 to $20, right? This is what you see from this plot, that most people almost see 50 for each. So almost 50% of the people paid a bill of around 10 to $20, and but there are a few people who paid higher also. The height of these bars is very small. That means there are very few people who are falling here. So a few people paid tip of, no, sorry, this is total bill, not tip. So a few people had a total bill of between 40 to $50, but most people had a bill between 10 to $20. Do you follow, guys, what this histogram is telling you? Any doubts on this? Any doubts on this, guys? What is this histogram telling you? This is on the total bill. Okay, so this also tells you the minimum. You see the minimum is very close to 0. So that means there is somebody who probably had maybe 50 cents as the bill. Not 0 exactly, because 0 is here, but maybe $1. $1 as the bill. Okay. Now next, similarly, we can have a joint plot. What is a joint plot? So it is giving you. So joint plot is used when you want to get a scatter plot and at the same time you want to see a histogram also. So you see this, I am looking at tip and total bill. So I have two variables here. I have tip and I have total bill and I have a scatter plot between the two. Okay. And at the same time, what else do I have? At the same time, I also have their histogram. So this histogram is for what you have on the x-axis, which is total bill. This is total bill. And this histogram is for tip, what you have on the y-axis. Okay. So this is called the joint plot because you are having two things in the same plot. So this gives you more information. You get to see the histogram as well as the scatter plot. Okay. This is also a joint plot, but this is between, this is basically the same, but what I have drawn here is I have given kind is equal to rig. So this we will come to know this later when we do linear regression. So this is coming from a linear regression, which we will study in details maybe after a few weeks once we start with machine learning. So right now you can ignore this. We'll come to this back. Okay. Similarly, we have why we use frequency in y-axis of histogram. Yes, yes, Arpita, that is correct. That the function will automatically calculate. You don't have to give that. Okay, so you just specify the variable. The function will automatically calculate the frequency for you. See, I have just specified the variable here. The heights of the bar are automatically calculated. No, that is for the pair plot. That is for this, not for the histogram. Okay, that is for this tip. This also is a variable, right? And this is one variable. So that y-axis that you see is for this tip, not for the histogram. Histogram is by default calculated. No, Amit, tip is not a function. Tip is the column. Tip is the column here. This tip. It's not a function. It's the column. But why did I not write data frame then the column? Because I have written data here tips. So Python understands that these are columns from this data frame. Okay. Because I have given data is equal to tips. Data is equal to tips is nothing but name of the data frame. Okay. This tips is the data frame. So Python automatically understands that these are columns which are coming from this data frame because I have given data is equal to tips. Okay. So that is how Python knows it. Similarly, one last plot that we will see is the pair plot. So the pair plot is also useful. Bivariate means two variables. Okay. Two variables at a time. Univariate means one variable. We discussed this yesterday, right? Histogram is univariate analysis because you are studying only one variable. But what you have here, for example, in the scatter plot is bivariate. Bivariate means two variables. That is why I am passing two variables here. One variable is total bill, the other variable is tip. Okay. So total bill is one variable, the other variable is tip. Now let us come to pair plot, which is also very interesting. So here what do we get? We can plot a pair, we can plot a scatter plot, and we can give different colors based on, let's say, gender, for example. Okay. So here, look at this plot. What have I drawn here? I have just given the name of the entire data frame and I have given hue is equal to the gender. So hue is what decides the color. So here I will have different color for male and for female. So you see this, I have different color for male and different for female. So blue means male and green means female. So let's say if your goal of analysis is to find out whether males are paying higher tip or whether females are paying higher tip, then you can draw this particular plot, and you can use the hue parameter. Hue parameter means you can give different colors, and you make sure always give something which is non-numerical here. Don't give something which is numerical. Okay, so if you give, let's say, you can give time, you can give day, you can give smoker or not, but you don't give tip here, otherwise you will get many colors. You will get one color for every number. So for every unique value of a column, so whatever you give here, whatever column you give here, for every unique value of that column you will get one color. So if you give a numerical column, the numerical column will have many unique values. So for every unique value you will get one color, which may not make sense. So you always give something which is non-numeric here. Okay, that is why gender or time of the day or so on. Okay, so here what do I see? So look at this. I get a matrix where I have, see, total bill. Total bill is my y-axis here, and what is my x-axis? My x-axis I can see at the bottom, it is total bill once again. So it is total bill versus total bill. So this doesn't make much sense. What you should look at is this plot, maybe this plot. So what do we get here? We have tip and we have total bill. So this maybe tells us that do people who get a higher bill pay a higher tip, which is true, right? If you get a higher total bill, obviously you will pay a higher tip, and that is why I see this line kind of a pattern here, because as this increases, my tip also increases. Now within that we can analyze the gender also. How is gender influencing it? So blue is male and green is female. So who do you think pays a higher tip? Looking at this diagram, who do you think gives a higher tip, male or female? Yes, exactly. So from this diagram, it looks like male gives a higher, male give a higher, males give a higher tip. You see, these are all blue. So all blue, all these which are higher on the tip axis. This is my tip axis. So the higher on this axis, the more tip that person is giving. So all the higher ones are mostly blue. Okay, the greens are situated here. So that means they are paying, on an average, they are paying lesser tips. Okay. So a lot of information can be done without running any algorithm. By just looking at the plot, you can get a lot of information. So that is the goal of these codes. You don't get a lot of information, but very basic information. So for example, here we got to know that males pay a higher tip than female. We got to know that as your total bill increases, the tip amount also increases. So these are very basic information that we got by just looking at the plot. We did not use any machine learning algorithm for it. Later, of course, we will start with machine learning algorithms. Then we will see these in details. But there are thousands of plots like this. Of course, we cannot go through all of them. So some of the plots which are given here, we will come back to them. So for example, regression plots, we will see this after we have learned what is regression. Then we will see. So for example, we have this heat map here, which basically gives you the correlation. So what is correlation? First we will see what is correlation, and then we will come back and look at this plot once again. Okay, but for now I think whatever we have learned so far, we have learned what is a histogram, we have learned how to draw a histogram, we have learned what is a scatter plot, we have learned how to draw a scatter plot, and we have also learned how to add different colors to a scatter plot based on a non-numerical variable. Okay, so your this week's assignment will be based on these questions. Okay, based on whatever you have covered. So this is all I had for visualization. So visualization is a world in itself. Of course, it is not possible for a short course like this to cover every single plot that exists in visualization, but I have covered all the popular ones which are most commonly used. But again, these are not exhaustive. You might have to visit the home page and get the exact chart that you may need once you start working in data science. But for now, I think these are the most popular ones which will suffice. Okay. So I need a few more minutes to cover this data manipulation. So do you want a break now? And so I will need maybe half an hour more. Is that okay, guys? I will need half an hour more to cover the manipulation part also. So do you want a 5 minutes break now and then we should start? So let's learn the basic of data manipulation. So as somebody was asking, I think it was Anil who asked, what about missing values in a data frame? So let's start from missing values. Okay. So we will talk about missing values. So what are missing values? So whenever we try to analyze data, so often we encounter missing values in our data. Okay. So some values might be missing. So for example, if you have to fill a form, sometimes what we do to save our time or just out of laziness, we don't fill the form entirely. We just skip uh, uh, a few details that is not mandatory. We just skip that, right? So what results because of that is you get null values. So for those places you will have null values. So for example, in the previous data that we were looking at, let's say this one. So let's say if somebody did not tell their whether he or she is smoker or not, then you will have a missing value here. If some customer did not tell to the person who collected this data, if somebody did not tell him whether he or she was a smoker or not, then you will have a missing value here. Then it will be difficult for us to analyze because some of the values will be missing. So missing values always creates a problem. So it is always that we either delete the missing values or we try to impute the values with something. Okay. So for example, if there are 30 students in the class and you know the marks of 29 students and you don't know the marks of, let's say, one student, how much he got, you don't know. So probably you may take the average. You may take the average of the entire class and say that this is probably the marks which this student got. Okay. Or you can maybe delete that student's details entirely and then analyze the data. Okay, so we will see this in details. As we start with algorithms, we will see how each algorithm is affected by missing value. But right now our goal is more towards the coding part, that how do we identify missing values in data. Later we will see how do we replace missing values with something which makes sense. But for now, it is important to identify missing values. So that will be our first goal. So I will import my numpy and pandas library first. Then I'm creating a data frame here, and notice I have given np.nan. So np.nan is what represents missing values in Python. Okay, so let me run this and then run this. So you see these nans, nan means these are missing values. Okay, so these are values which we did not have, so these are missing values. How did I define that? I defined that using the np.nan function. I use the np.nan function. Okay. Okay. Now, first of all, let us see how to delete missing values. Let's say I want to delete all the missing values. So what I will do, I will just write data frame dot drop na. Okay. I'll write data frame dot drop na, just like you used data frame dot drop to drop columns or to drop rows. We will use data frame dot drop na. Na means the missing values. Okay. So data frame dot drop na, what it would do, see what it has done. It has deleted all the rows which has missing value. So this row has a missing value, this row has a missing value. So both these two rows are deleted, and what we have is only the first row because it doesn't have any missing value. Okay. So actually what happened here is there was a parameter here, access is equal to 0. because I mentioned earlier, right, that access is equal to 0 by default. So by default, that access was equal to 0, and that is why it deleted the row which has missing value, not the column. Okay. If you want to delete, so again, if I use access is equal to 0, I get the same result. I get only the first row, and the rows which have missing values are deleted. Similarly, if I want to delete the columns which has missing value, I will write data frame dot drop na, and I will give access is equal to 1. So this time the columns which has missing value, which is column A and column B, will be deleted, and only column C will remain. So I have only column C here. Do you follow this, guys? How to delete the row which has missing value, or how to delete the column which has missing value? Did you follow this? So by using the same parameter, access is equal to 0. If you give access is equal to 0, it will delete the row which has missing value. If you give access is equal to 1, it will delete the column which has missing value. Simple. Okay. Now let us say I want to delete the rows or the columns, but I want to keep a threshold. I want to delete only if it has more than two missing values. Okay. I only want to delete the rows or the columns which has two or more than two missing value. Then what will I do? I will use the same function dataframe.dropNA, but I will use the threshold function, threshold parameter within that function. Okay, so it goes like this. You write thresh is equal to 2. What does this means? This means that it will delete only, and I have given access is equal to 0. That means it will delete the rows. So it will delete only those rows which have two or more than two missing values. Just for one missing value, it will not delete. Okay, so it has deleted only the third row because the third row has two missing values. It did not delete the second row because it has only one missing value. So only those rows which have two or more than two missing values will be deleted if you use the thresh function. Do you follow? Okay, now we have talked about deleting the missing values, but sometimes a lot of rows will have missing values. So if you delete all of them, you will be left with almost nothing. So Bharti says my comment in the line says opposite. Yeah, it doesn't say opposite, it says the same, but instead of saying NAs, I have written filled here. Bharti, I have said filled here, so I'm saying the opposite of what I said, so it is correct. So delete all rows less than two cells filled, or delete all rows more than two cells missing. It means the same. Okay, so this is also correct, another way of saying it. Okay, so now if you delete all the missing values, sometimes you may be left with a very few rows remaining in your data. So almost half of your data might be lost if you delete all the missing values. So sometimes what we do, we don't delete the missing values, we instead fill them with something appropriate. Now what is that appropriate thing? We usually take the average or the median. We will talk in details about this once we start machine learning. Sorry guys, I had somebody at my door. Okay, so other times when we don't want to delete all the missing values, we replace the missing value with something more appropriate. Okay, we usually take the mean or the median, but we will have a separate in-depth discussion on this. Yes, that's what we learned. If you want to ignore them, just delete them. So that was the first method, Bharti. If you want to ignore them, just delete them and then consider the remaining. So that is the first method which I talked about. But now if you want to use the second method where you don't want to delete them, you want to replace them with something, that we will see now. No, it's the same thing, right? You ignore them or you delete them, it's the same thing. So what you can do, you create a copy of your data frame, and in that copy you delete. Don't delete it in the original data frame. Okay? Are you getting what I'm trying to say? Don't delete it in the original data frame, just create a copy of your data frame and there you delete it. And then you again get it back. Okay, if you want to ignore them. But right now I will tell you how can we fill the missing values with something. If there are large number of columns which can be no, I'm not getting your question actually. What are you trying to say? So you don't want to delete them, but you want to ignore them. But aren't they the same thing? You ignore them or you delete them. It's the same, right? Because you are anyways not considering them. Aren't they the same? Because you are anyways not considering them, right? When you are analyzing a column, if you delete the missing values or you ignore the missing values, it's the same thing, right? Because you are anyways not considering them. Okay, in a row, 1000 values with only 3 missing. Okay. Yeah, there I want to lose. No, why do you want to lose 997 values? You will lose only 3 values. You are deleting the missing values, right? You are deleting the missing values, not the column. No, if you delete the row, you will miss only 3 rows, right? Not 997 rows. Yeah, so only 3 rows you will miss. So which is okay, right? That's what you are anyways doing. Okay. So I think there is a doubt here. Let me explain, Bharti. I'll try to explain. So let's say you have EMPID, you have name, you have age, you have salary. So you have some numbers here. You have, let's say, missing value here. This is missing value, okay? And you have another missing value here. Okay, so this is the data you have. So now if I want to delete, let's say I want to analyze the column age. Okay, I want to analyze the column age. So I'm not saying you to that drop this entire row. Okay, I'm not telling you to drop the entire row. Only when you are analyzing age, then you drop these two. So that means you will consider this one, this one, this one, and this one. But don't delete the entire row. Okay, don't delete this. Only while you are considering the column, you delete these two values or ignore. It's the same thing. Okay, you got it? So that's what I'm saying. Okay. Okay. Now coming to filling a missing value, the syntax is simple. So just like you use drop NA to delete missing values, you will use fill NA. Okay, so this way it is easy to remember. If you want to drop, you use drop NA. If you want to fill, you use fill NA. So how will you do? So for example, let's say I want to fill these two values. There are two missing values in age column If I want to fill them, what will I write? I will write data frame dot, no, first I will have to select that column, right? So data frame, then age dot fill NA. Okay, then I will write value is equal to whatever I want to fill there. Let's say I want to fill 50. So then that means this will be 50, this will be 50. So this is how I will fill the missing value in this column. Okay, do you get it, guys? How do you fill the missing values in a particular column? By using the fill NA function and writing the value that you want to fill. So for example here, so here what I have done is I have filled the entire data frame with this value. The value itself is fill value, a text. So what happens now? So this is the missing value I had, right? I had one missing value here and two missing values here. Now all of that will be replaced with fill value. So you see I have fill value, and fill value here. Okay. In this case, I am filling the missing value with 2. So I have 2 here, 2 here, and 2 here. Okay, all the missing values were filled by 2. If you want to fill it column wise, then you use this syntax. You first select the column and then you write fill NA. So here I am filling the missing value in column A by the average of column A. Okay, so where is my column A? My column A is this. What is the average of column A? It is 1 plus 2 divided by 2, which is 1.5. So I am filling the missing value with 1.5, and so I have this 1.5 in column A. Okay, do you follow this, guys? So this is how you fill a missing value, how you delete a missing value, and this is how you fill a missing value in a data frame. Do you follow, guys? Okay. So now moving ahead, this is the same which I have shown you. I have just dropped the missing value and kept it in another data frame called cleaned. And if you want to create a new column with just nan missing values, you can write like this. We have seen this already. How do we create a new column? Just write the name of the data frame and give a new column name and write whatever value you want to assign in that column. In this case, I'm assigning a column only nan. Okay, now this is important. How do you identify missing values in a data frame? So let's say you have a data frame and you have to know that how many missing values are there in each column. So for that, what we use, we write data frame dot is null dot sum. Okay, what this will give you is it will give you column wise how many missing values are present. So if this is your data frame, see it is giving me column A has one missing value, which is this. Column B has two missing values, these two, and column C has zero missing values. Okay, so this is how you identify missing values. So this should be your first task. Whenever you get a data frame, your first task should be, how do I identify the missing values? Only after that you will either delete them or you will replace them with something meaningful, right? But the first task will be, how do you identify how many values are missing? Only after looking at how many values are missing, you will take a decision. If there are very few, you may probably delete them, but if there are too many, you may want to replace them with something appropriate. No, missing values, Bharti, you look with respect to columns, not with respect to rows. Okay, you always do that with respect to columns, because that is how you fill them. You don't fill the missing values with respect to row. You fill missing values with respect to column. Okay, why do you fill with respect to column? Because let's say if age is missing for some students, let's say this is employee data set and age for some employee is missing. So how will you fill the missing age for that employee? You will look at what is the age of other employees, and then only you will be able to make a guess, right? You will not look at his employee ID or his name and then say that this is his age. By looking at the name of a person, you cannot say his age. But by looking at what other employee's age is, you may be able to guess. Okay, so filling missing values is always done column wise, or even identifying missing values is done column wise, not row wise. Okay, we always do it with respect to row columns, not rows. If you just write data frame dot sum, what this will give you is it will just add the values present. So again, this will also be done column wise. So column wise, it will give you the sum of each column. Okay. Now one very important function, very useful, is group by. So people who know SQL will already know this. What is group by? Okay. So group by is what you use when you have to aggregate based on a column. When you have to aggregate data based on a column. So one, for example, let's say I give you data on sales of a store. So let's say you have a store, let's say a chain of store, let's say CCD. So you have CCD, sorry, you have CCD. Let's say this is store ID. This is the city in which the store is located, and this is the sales of the store. So let's say store ID is 101, city is Bangalore, sales is, let's say, 10 lakhs. Store ID is 102, city is again Bangalore, sales is, let's say, 14 lakhs. Let's say sales store ID is 101 again, city is, let's say, Mumbai, and let's say sales is 15. Store ID is 102 again Mumbai, and let's say it is 16. 100, let's say Bangalore, it is 18, and so on. So similarly, let's say you have many other cities also. Now I want to know what is the average sales of CCD in each city. Okay, this is my question. So these are very common questions in SQL. So what is the average sales of CCD in each city? So that means what you have to do, you have to take, let's say, the first city, Bangalore, and calculate the sales in each CCD store in Bangalore, and then take the average of it, right? So what you need this column and you need this column. This column is not required. You don't need this column. So what will you do? You will do a group by. So this is what you would do in SQL also. The same function exists in SQL. So how would you go about this? You will write the name of the data frame. So let's say this is the data frame. You will write data frame dot group by. Okay, this is how it starts. Then you will write the name of the column on which you want to group by. So on which column do you want to group by here? Is it city or is it sales? On which column do you want to group by? Yes, it is city. Okay, so you want to group by on city, so you will write city here, and then what do you want to do? You want to perform some operation after grouping it. So that operation on which column do you want to do? You want to do it on sales. Sales dot mean. You will write mean here, which means you are calculating the mean. Okay, so that is how it is here. So here I have a different example. This is the data set that I have. I have company, I have name of the person, and I have sales. Okay, and you have to tell me the average sales in each company: Google, Microsoft, Facebook. So I'll do data frame dot group by. I have to group by on the company, and then sales will be like this. I'll write sales here dot mean. So this will give me the mean of sales. So that is what I get. I get for Facebook 296, Google this, and Microsoft this. So this is where group by is used. Okay, so right now I have group by based on just one column. Sometimes you may have to group by based on multiple columns also. Okay, so this is how group by works in Python. This is exactly similar to in SQL. In SQL also you have a similar function, group by, which is used for the same purpose. Okay, so I have some more examples here. here I'm trying to find the standard deviation. So yesterday we talked about standard deviation, right? So here I'm trying to find standard deviation instead of the average. So I'll just write std. Std is the function which gives you standard deviation. Similarly, I can find the minimum also, I can find the count also, or any function that I want to use, I can write it here, not just average. Okay, so I have one more example here. This is one more example. So this you can probably look on your own. Now I have what is called merging multiple data frames together. Okay, so there are two types of merging that we'll be learning. One is a normal merging where you just place one data frame on top of the other, and the other is join. Joins, I think you would have probably seen. Okay, so let me take another page. So we are almost done, guys. Just I'll take another 15 minutes. Okay, please bear with me. Okay, so first let us see a normal concat operation. So let's say I have a data frame here. Okay, I have employee ID and I have name of employee. Okay, let's say I have only these two columns and I have data till 2015. Now let's say 2018. Now we are, let's say we come to 2019 and some new employees join the company. So once again I'll have data in the same format. I will have employee and I'll have name. Okay, now I have to merge these two data sets together. So this is data frame 1, this is data frame 2. I have to merge them together. How do you think I should merge them? Should I merge them like this, data frame 1 and data frame 2? Should I merge them like this, or should I merge them data frame 1 plus data frame 2? Should I merge them like this? I should use 1 or I should use 2? Which one should I use? Yes, exactly. This makes sense, right? Merging them like this doesn't make any sense at all. So how do we do that? We will write pd.concat. So this concat function comes from the pandas library. So pd.concat, and whichever data frames you want to merge, you pass that as a list. So I will write data frame 1 comma data frame 2, and then I write access is equal to, what should I write? Access is equal to 1 or 0? What do you think? Access should be 0 or should be 1? It should be 0. Okay, because I'm merging row wise, right? I'm merging row wise, not column wise. Okay, so this is what I'll be using, and I can give some name to it. Let's say df. So this joining is defined by access is equal to 0. So now you would have guessed what would happen if I write access is equal to 1. Access is equal to 1 means you will be doing this one. So depending on the situation, you will either pick this or you will pick this. Okay, depending on your requirement, you will either pick this one or you will pick this one. So you understood this? pd.concat, the same function is used. Yes, 0 is for rows. Okay, so the same function is used for both. The function is pd.concat, and then as a list you can pass your data frame. So all data frames that you want to merge you can pass here, and then you write access is equal to 1 or 0. Okay, this is how you join two data frames. So notice I have done a normal join. I have just placed one on top of the other, or I have placed one besides the other. I have not used any key to join them. So whatever joins you probably learned in your SQL classes or in your graduation, that those were different joins. Okay, they were based on a common key. But right now I have not used a common key. I have just put one on top of the other. Okay, now let us look at the other join that we mostly use, okay, which is called merging basically, okay, or also known as joins in SQL. Okay, so for the first, let us quickly study the theory. So most of you would already know this. So there are different kinds of joins. Let us study them with a Venn diagram. Okay, let's say I have two data frames A and B. So if I want only this, what is this called? Anybody? What kind of a join is this? Yes, this is inner join, not full join, Anil. This is inner join. Okay, this is called inner join. Similarly, if I do this, what kind of a join is this? This is outer join. No, this is outer join, Bala. Okay. Oops. What kind of a join is this? This is left join. Okay, we can clearly see, right? This is left join. And similarly, what kind of a join is this? This is right join. Okay. Now let me explain all of these with an example. Let me take a small example where I just have employee ID and name. This is my first data frame, and I have another data frame where I have employee ID and let's say I have his salary. Okay, let's say 1, 3 and 5, and name is let's say A, B and C. Employee ID is let's say 3, 4 and 5, and salary is 10, 11 and 12. Okay, now if I do a inner join, what do I get, guys? Can somebody tell me? First of all, tell me how many columns will I get? If I do an inner join between the two, how many columns will I get? How many columns do I get? 4. Why 4 columns? I'll get 3 columns. Why 4 columns? I'll get 3 columns, right guys? I'll get employee ID, I'll get name, and I'll get salary. Right? The employee ID is in both. So of course it will not repeat, right? Now inner join, what values will I get? Yeah, later we can select based on our requirement, but by default we will get these 3 columns. Okay, so employee ID, we will get only those employee IDs which are common in both. Okay, that's what a inner join does. Look at this diagram. What are we getting? Only things which are common in both. So only employee ID 3 and 5 is common in both. So 3 and 5 we will get, and the name corresponding to this and the salary corresponding to this. So this is an inner join. Okay, everybody understands this? Similarly, let's do an outer join now. If I do outer join, what will I get? Yes guys, outer join, what will I get? Yeah, I will get everything. Bharti is right. Okay, I'll get everything. So you look at the figure, look at the diagram and you understand. Is anything left out in the outer join? No, nothing is left out. I'm getting everything. So I'll get everything. I'll get 1, 3, 5 and then 4 and 5 also. So 1, 3, 5 means A, B and C. 4 and 5 they do not have any name. Okay, no, 5 I will not get again. Okay, 1, 3, 4 and 5. Okay, this is what I'll get. Yeah, so for 4 there is no name available, so I'll get a missing value here. Salaries for A, I don't have the salary for A, so I'll get a missing value here. For B I do not have, I have 10, so I'll get 10. For 5 I have 12, so I'll get 12. For 4 I have 11, so I'll get 11. But I will get some missing value. So notice this is a missing value, this is a missing value. So in outer join, you get all the data, but some places you might get missing value if the mapping is not present. Okay, so this is outer join. Everybody understands this? Do you follow, guys? Okay, now coming to left join. So how do you think a left join will happen? So I have employee ID, I have name, I have salary. So in a left join, whatever data frame you keep on the left, that will be taken as a base. Okay, so you notice the diagram. What does the diagram tell you? That you will get all the details of your left data frame. Okay, so let me write down all details of my left data frame. So I have 1, 3 and 5, and I have A, B and C. So I have written down all details of my left data frame. Now what will I pull? I will pull details which is available from the other data frame. So what is available? For A, is the salary available? No. So I will give a NA here. For B, is the salary available? Yes, it is 10. So I will write 10. For C, similarly, it is 12. It is available. So this is what I will get for left join. Do you follow, guys? How did I get a left join? So you will get everything from your left data frame, but only things which have a mapping from the right data frame. Okay, things which do not have a mapping will not be available. You will get a missing value for that, but things which have a mapping will directly appear. Okay, I'm sorry, here this will not appear. You will not get this. I made a mistake. This row will not appear. You will, no, I think I'm right. You will get this. Yeah, you will get this. This is left join, right? So you will get your left table entirely. So this is correct. Okay, so this is how you get a left join. Your entire left data frame, the data frame which is on the left, will entirely be present, plus whatever is having a mapping with the other data frame will be pulled. Whatever is not having a mapping will be left as a blank. Okay, and similarly for right also. Now you would have guessed for right. Okay, so this is the understanding. This is the understanding of joins in Python, which is the same as in any other language. Okay, now let us see how do we do this in codes. So in codes it is very simple. So we just write, let me show you directly here. We will just write pd.merge. Okay, I'll show you here itself. So you write pd.merge function is used. Okay, then you write the name of the data frames, let's say df1 and df2. Then you write on. So on means on which key do you want to merge. You will have to define that. Okay, so here for example we were merging based on employee ID. So you will have to write that employee ID. So I will write emp ID because I am merging on employee ID, and then you write another parameter called how. How basically tells how do you want to merge. So what are the options it can take? How can take these options. It can take left, it can take right, it can take inner, it can take outer. So any of these options you will do depending on what you want. You want an inner join, you write how is equal to inner. You want a left join, you write how is equal to left. Okay, so this is how we do it. So I have written pd.merge. Then these two data frames I have given A and B. How is inner and on is key. So some examples are given here, okay, based on these two data frames. Similarly, how is right and on is key, and so on. You can use multiple keys also to join if you wish. Okay, do you follow that, guys? Did you follow this syntax? Okay, so this is how we do joins in Python. I think this is all I have. So here I have certain codes which tells you how do you read a CSV file in Python. So for example, if you want to read a CSV file, you write pandas.read_CSV and you write the name of the file. Okay, whichever file you want to read. So here I have not given the location. If you don't give the location, whatever location your file is present. So for example, my codes is present in this folder. See, I'm right now looking at data manipulation code. Data manipulation code is present in day2. It is here. It is here. So whatever CSV files I have in this folder, I can directly read it without giving the location. But if you have a CSV file in some other location and you want to read that, then you will have to give that entire location. Just paste that entire location in Unix format. Okay, you'll have to paste in Unix format. So don't just copy paste from here, because this is different than Unix format. Unix format uses a slash. This is a backslash. Unix format uses a forward slash. Okay, so either use double backslash or use forward slash. So give that entire location here within quotes. Then you will be able to read any CSV file in Python. And after reading, it will be as a data frame. And then you already know how do you do a basic analysis on a data frame. Okay. Similarly, if you want to read a CSV or a Excel file, you use read_Excel and the same syntax. You write the name of the Excel, and since Excel will have different tabs, you write the name of the tab also. So sheet name, which sheet name do you want to read? There will be 3 sheets in Excel by default. So whichever sheet you want to read, you write that name. Okay, this is how you write a CSV file. So let's say you have a data frame, you want to write it. You want to write it to a CSV. You write the name of the data frame .to_CSV, and then you write the name of the CSV file that you want. Okay, and then index is equal to false means you will not get serial number. Otherwise, you will get serial number as index. So for example, we had the tips data, right? I think we had it here. So we have the tips data here. So if I want to, txt file is also similar, Bharti. So if you want to read a txt, so there are many different formats. Whichever file you want to read, you just Google read a txt file in Python. For example, you don't have to remember, though you will remember after you practice. So let's say read a txt file in Python I wrote. So in the first result itself you will get. So this one, let's say. So see, this is how you read a txt file. Okay, this one, this code. You just write open and write the name of your file. That's it. Okay, so don't worry about remembering all of this. Save your memory for machine learning, because there you will have to remember a lot of concepts. So you don't have to remember the codes. Okay, but usually you will receive your files as CSV. So CSV, how to read a CSV, you should remember, and it is not difficult. Just read_CSV, read_Excel. Okay, so whatever homework I'll be sending you, that will also have a CSV file. So you will use this command to run it, to read it. Similarly, you can read HTML also. So similarly, read_HTML you will be using. So this command, read_HTML, and so on. Okay, this is how you read different formats of CSV files. But for TXT, it is not read_TXT. Okay, that is the difference. It is some other command. So this is all I had for today. We covered a lot. Let us quickly revise whatever we covered. We covered a lot of things today, almost 4 hours of class. I'm very tired also talking for 4 hours. But yeah, let's do a quick revision. So guys, this class was very important. Please revise the recordings of the class multiple times if you have to. I'll send you the homework by tonight or maybe by tomorrow. Okay, by tomorrow I will send you the homework. Until you receive the homework, please revise whatever has been covered in the class. I'll share the videos immediately. So in half an hour or maybe in 1 hour, I will share the videos, the recordings, and whenever you get time, you start revising it. And by tomorrow, I'll be sharing the homework also. Okay. But a lot of things were covered. Please make sure you get a good start, because this is where we are starting. So take a good start. Okay, don't keep anything pending for the next class, because next class will be new topics. So if you keep things pending, at one point it will become too much to control. Okay, so keep clearing things during as and when the classes are over. Okay, so what did we cover today then? Where did we start today? We started from two new data types, which is first is, okay, we covered arrays, right? We covered arrays, which comes from the numpy library. Okay, arrays are similar to lists, but they can have only one data type. Remember, they can have only one data type, and they can be two dimensions. Okay, comprehension also. Okay, I'll come to comprehension. They can go into two dimensions also. Arrays can go into two dimension. And the other advantage is they support broadcasting. Okay, which is basically perform operation on individual element. Okay, so these are the characteristics of an array. Okay, yeah, before that, let's finish comprehension. So what did we see in Python comprehension? What was the syntax? You first do whatever you want to do, and then you write for I in, let's say, a list. This was the syntax, right, guys? You first do what you want to do, and then you write where is that variable coming from. You can use a if condition also in a list. So I into 2 for I in a list if I is whatever condition. If I, so you can write some condition here. Okay, so this is the condition. Again, you do what you want to do, then you define the variable and then the condition if needed. Okay, so this is how comprehensions are used. We saw one nice example of application of comprehension when you have to find a minus b, for example. What do you write? You write I for I in a if I in b. Okay, sorry, if I not in b, because I am doing a minus b. If you don't write not in b, it becomes a intersection b. Right, guys? Remember this? Guys, are you following? Okay. Next, we move to data frames. So data frames are the most important data types, because whatever external data we read into Python, that will all be in the form of a data frame. Okay. So we saw that data frames are just a group of series connected together. So they will have rows and they will have columns. So let's say we have these four columns, sorry, and you will have some rows. Okay, and let's say we call it data frame. So how do you define a data frame? You write pd dot data frame, and then you write your data. You define your data here. Then you write index. If you want index, you can write. Otherwise, by default, you will have serial number as index. And then you write columns is equal to whatever columns you want to give. So I have 4 columns here. So I'll have to give 4 ABCD. Then only I'll get this data frame. So this is how you define a data frame in Python. Next, we learned how do we access individual columns or rows from a data frame. So you write data frame and then the column name to access a column. If you want to access multiple column, you will write all the columns as a list. Okay, this is how you can access 2 columns, A and B, but only 1 column, this alone is enough. 2 columns, you have to give double square brackets. Okay, then we learned how do we access rows or columns using the row labels. Using the row labels, you have to use data frame dot loc function. So dot loc, if you write, let's say A and let's say B, What does this mean? This means that you have some row, the label for that row is A, and you have some column, the name for that column is B. So that is what you are trying to access. If these do not exist, you will get an error. Okay, this is not rarely used, this is very rarely used. Okay, but iloc is very popularly used. Iloc is used when you want to access rows and columns by their indexes or by their serial number. So for example, you might want 0 0. This means you want 0th row or the first row and the first column. Okay, you can use the colon also here. The colon means from 0 till the end. You have left it blank, it means from 0th row or the first row till the end, or all the rows, in other words, all the rows, and from 5th column till the end. This is what it means. So I means you are accessing using the index. Okay, we also saw how to apply conditions on a data frame. So you can write data frame, and on whichever column you want to apply the condition, you select that column. So let's say you want to apply on column 1 and apply that condition. So this is a condition being applied on one column of a data frame. Okay, so the result will be all the rows where this condition is true. Okay, you can give multiple conditions also. So condition 1 and condition 2. Okay, this can be data frame, and let's say column 1 greater than 5. This can be data frame, and let's say column 2 less than some number. So you can give multiple conditions separated by and or. Okay, this is what we saw in the data frame. What else? Okay, then we saw missing values. Let's finish this, then we will revise the visualization part. Let's finish the missing value part. Yeah, so next we learned how do we identify missing values. So we identify missing values using, first let us see how do we identify that. So data frame dot is null dot sum. Okay, I think this is not here. So dot is null dot sum. This is what we use. So what will this give you? Anybody? What is the output of this? What is the output of this? Data frame dot is null dot sum. So it will give you column wise count of null values. Yes, Arpita, you are right. Okay, column wise count of null values. Okay, now this way you can identify how many missing values are there in each column. Now if you want to, let's say, delete them, you may not want to delete them always, but let's say if you want to delete them, then what will you do? You will write data frame dot drop, and then you will write the name of the column, of course. So whichever column you want to delete, let's say C1 you want to delete, and then you will write access is equal to 1 because you want to delete a column. Okay, so this is how you delete a column. Sorry, drop NA. Yeah, okay, this is, so if you don't write NA, you are basically deleting the column, but if you write NA means you are deleting missing values in that column. Okay, or deleting the rows, deleting the columns which has missing value. Then you will not write this, you will just write data frame dot drop NA. Okay, did you follow that? There was a small confusion. If you write dot drop NA, that means you are deleting all, and access is equal to 1. This means you are deleting all columns which has missing value. If you write access is equal to 0, it means you are deleting all rows which has missing value. Okay, but if you want to delete a column, irrespective of whether you have missing values or not, you just write data frame dot drop, not NA. NA is used when you want to delete missing values. But we very rarely drop missing values directly. Is null or nan? No, here you write is null. It is null. Okay. Next, we saw how do we replace missing values. So this is what is more important, because we mostly don't delete the missing values, we replace them with something appropriate. So how do we do that? We write data frame So let's say you want to replace missing values in column C1. So you will write dot fill any. Okay, and then you will write the value with whatever value you want to fill the missing value. You write that value here. So this is how you fill a missing value or replace a missing value with something. Okay, what else did we see? Then we saw the concat function, right? Concat function we just saw. It is like adding two data frames like this or like this. Okay, we use pd.concat function for that. You write the name of your data frames, all the data frames that you want to merge, and then you write access is equal to 0 or 1 depending on which one you want to do. Okay, this is simple. Then we saw group by. Group by is where you want to aggregate a data based on a column. So the syntax for that is data frame dot group by. Then you write the name of the column on which you want to group by, let's say C1, and then you write the column on which you want to perform the operation after grouping by. So why are you grouping by? Because you want to perform some operation. In the example which I gave, you wanted the average sales of CCD stores per city. So this will be your city and this will be your sales. So you can write the other column. So let's say sales dot mean if you want to find the mean. So this is how you use group by function. Okay. Then we saw joins. So the syntax for that is pd dot merge. Then we write data frame 1, data frame 2. Then we write on. We write the columns on which you want to join. And then we write how is equal to. We write whether we want left, right, inner or outer join. Okay, this is the syntax to do joins in Python. And then we saw how do we read CSV files. So read underscore CSV. If you want to read Excel files, read underscore Excel. If you want to read HTML, read underscore HTML, and so on. Okay, what else? We also saw some visualization today. We saw how to use the matplotlib and the Seaborn library. So first, coming to matplotlib, we use plt.hist function. If you want to draw a histogram, we use plt.plot function for a line plot. We use plt.scatter if you want to draw a scatter plot. Okay, so these are the three commonly used visualizations that we saw. This is from the matplotlib library. Then in Seaborn, so Seaborn has some more advanced visualizations. Okay, in Seaborn, the same histogram we saw with a different name. We write sns.dist. So this represents a histogram in Seaborn library. Both will be the same. Okay. Then we also saw sns.joinPlot. So join plot, remember, it gave you a histogram plus a scatter plot. Okay. So you had variable 1 here, variable 2 here, and you had a histogram for variable 2 here and a histogram for variable 1 here. Okay, so joint plot gave you both. And finally we saw a pair plot. A pair plot which had the hue parameter. Remember the hue parameter which we gave as gender. So what this gives you, pair plot will give you plots between all variables in the data frame. Okay, so you will pass a data frame also here. It will give you a plot between every two variable in the data frame, and in the scatter plot you will have different colors assigned based on the gender. Based on whatever you pass as hue parameter, you will have different colors assigned. Okay, so based on the color also you might make a lot of sense out of the data. You might get a lot of insights. So for example, we got to know that males pay a higher tip than female just because we had colored them separately. If we did not color them separately, we would never know. Okay, so this is what we covered today in brief. Anything else which I missed or any doubts do you have, guys? I'm sorry I took the class very long today. It almost went for 4.5 hours now. So I'll try not to. I'll try that this doesn't happen again. We will make it 3.5 hours, but not so long. Okay.